Hi everyone, welcome to Vedantu JEE English. I'm Diksha Kaushal, your chemistry master teacher. So everybody in the chat box, am I visible? Am I audible to all of you or not? Everyone in the chat box. Yes, let us wait for the students to join in. So guys, today we are going to do a means chapter, and full chapter we are going to do today itself, right? So along with the very important previous year questions from JEE means as well as JEE advanced, right? So everybody in the chat box, if I am is visible and audible to you, then write it down in the chat box so that we can start the session. Okay. Yes, Yamini. Yes, Yamini, Janu, JEE, Afefa, Mohammed, RVK, Bhargavan. What beautiful name you guys have. Very good evening. Very good evening. So guys, are you all ready for Amines chapter or not? Right, because today we are going to do really interesting questions, right? And you know, Amines is one of the most easy chapter if we compare to other chapters like aldehyde ketones, carboxylic acid, or if you talk about alcohol, phenols, ethers, hydrocarbons, haloalkanes, halorines, right? There the content is like you have a variety of content, right? But in this chapter, it's not like you have too many reactions to remember, right? Specific questions are asked based on reactions as well, right? Based on distinguished test as well, and based on the basicity of amines as well. So these are the three topics from where the questions are asked from amines chapter, right? Okay. When will portion be completed? Today itself. I'll complete the lecture today itself. Okay, this chapter will be completed today itself. So you don't need to wait for any other part here, right? So yes. So are you all ready? Evening, good evening. So are you all ready or not? If you are ready, then I want green hearts in the chat box for amines chapter. And from here only we will, I think your organic chemistry will be completed. After that, you will be left with biomolecules that we are going to complete on Monday, right? Okay, everyone in the chat box, shall we start or not? I can't see the energy in the chat box, right? I want everyone to be energetic, right? This is a easy chapter, a scoring chapter. Predictable questions are asked from this. I'll also show you some advanced questions, right? It will be very easy for you to answer those questions. No doubt those questions are a little bit tricky, right? But it's not like they're out of your syllabus, right? It's just a combination of too many reactions, right? Okay. Yes. Video glitch, is it? Is there any video glitch? Is there any video glitch? Anyone? Okay. I still can't see the energy in the chat box, huh? I still can't see your energies in the chat box. Don't be so boring, yeah. Why you guys are so boring? Right? I thought JEE aspirants are very energetic. Huh? JEE aspirants, non-medical aspirants are very energetic, right? It's not like you are sitting there like this. That's not how engineering students should behave, right? Engineers are very famous throughout the world, right? For their nature, for their, very fun-loving nature, right? So you are going to be future engineers. Why are you behaving like such a sad soul sitting there? No, okay? So be happy that today we are going to complete this chapter full-fledged, right? Okay, so let us start, and I want the responses of all of you in the chat box. As I told you, I am not a robot who can teach here to the walls, right? I am not a machine who is you will send some codes. You are an engineer and you will send some codes to this machine and machine will talk like that only. This is a human being teaching you. So I want your responses in the chat box. Only then I'll be able to interact with you and teach you. Okay? Yes. Okay. Now let us start. Now, first thing is we are going to talk about what is amines, right? So can you tell me what is exactly amines? So this is ammonia. So if you replace the hydrogens of this ammonia, you will get the amines, right? So first thing is, if you replace only one hydrogen, you will get RNH2. If you replace two hydrogens, you will get R2NH. If you replace 3 hydrogens of ammonia, you will get R3N. Right, so these are the 3 amines what we have. This is ammonia. When only one hydrogen is replaced, that is called primary amine, 1 degree amine. When 2 hydrogens are replaced, that is called 2 degree amine. That is called 2 degree amine. When 3 hydrogens are replaced, that is called 3 degree amine. Right, that is called 3 degree amine. Right, so regarding the IUPAC naming, I'll teach you separately of all the groups that we have studied till now. Right, my total concentration will be to the reactions and distinguish test and what are the mechanisms, intermediates, right? Because IUPAC naming is somewhat similar of all the cases, right? So we will have a separate marathon lecture for IUPAC naming and common names, right? So these are the 3 amines, 1 degree, 2 degree, 3 degree, right? If you talk about aromatic thing, so in that case you will have aniline, right? In that case you will have this structure. This is called aniline, right? And aniline is also a very, very important compound, right? In JEE, they will ask you so many questions related to aniline and its reactions, how it is formed, the chemical properties of aniline, right? So this is called aniline, right? Okay. So now, as I told you, firstly, we will see what kind of structure it will have, right? So let us talk about primary amine firstly. If you talk about primary amine, it is RNH2, right? So that means, can I say it is R, 2 hydrogens. I am not drawing any 3D structure here, right? This is N, this is N. To N you have attachment of 2 hydrogens and 1 alkyl group, and there is 1 lone pair that is on the nitrogen, right? Okay, on the nitrogen there is 1 lone pair. Now can you tell me how many sigma plus lone pair it has? 1 sigma, 2 sigma, 3 sigma, 3 sigma plus 1 lone pair. So can I say that it is 3 sigma plus lone pair, that is equals to 4, right? So whenever your steric factor is 4, in that case we can say that this is sp3 hybridized, right? And sp3 hybridized means it is tetrahedral. So we can say that it is tetrahedral, right? This will be called as tetrahedral, right? What is exactly tetrahedral? Can anybody tell me? Can anybody tell me what is exactly tetrahedral? Anyone in the chat box? So this is tetrahedral, as you can see here, right? As you can see here, this is tetrahedral. You have 1 bond. It is like in 2D we showed tetrahedral structure like this. In 2D we show tetrahedral structure like this, but in 3D it is different, right? That is why I try that students should learn by 3D models, not by 2D, right? So actually when we make NH3, we say it's like this, right? This is lone pair, this is 1, this is 2, this is 3. But actually, do they look like this in one plane? No, they are not in one plane, right? For example, this is the lone pair. I am saying this is the lone pair and these are the 3 atoms, right? So basically, this is what a tetrahedral structure will look like, right? If you replace this, this is what a tetrahedral structure look like. Again, you rotate this, this is what a tetrahedral structure looks like. It has a 104. This angle throughout here is 104 degree, right? That is the angle that it has, right? So it has a 3D structure. This is R, this is H, this is H. Even for other alkyl groups, right? If you replace 2 degree, 3 degree amines also, that is also what we have. 3 sigma plus 1 lone pair, that is also sp3 hybridized, right? So in 2D, like this is actually the statement that I was showing you, right? This was actually the diagram. Actually it is in 3D, but how to draw 3D in 2D, this is how we draw it, right? So basically this is your tetrahedral shape, right? Next we are talking about is pyramidal shape of trimethylamine. Now we are talking about trimethylamine, right? Trimethyl means you have, here they are talking about shape, right? Let us talk about why they have called it pyramidal shape, right? Okay, so for that you need to understand one thing from chemical bonding, that when we talk about geometry, we talk about lone pair plus bond pair, right? We count that, but when we talk about shape, we only talk about bond pairs. We just ignore the lone pairs. So if you talk about anything here, we are talking about NH, we are talking about, let's say, R3N, this is lone pair, right? Definitely it will have a tetrahedral geometry. Why it will have a tetrahedral geometry? Because it is having 4 as the lone pair plus the sigma bonds, right? That is why it will have a tetrahedral geometry, right? Okay, but now can you see this thing, that if I ignore that lone pair, right? I am ignoring that lone pair. This is how it will look like. Now, what is this shape? This is like a pyramid. Can you see? This is like a pyramid. If I place a plane here, it will be like a pyramid only, right? Like a pyramid, right? So that is why it is called pyramidal shape. Its geometry is tetrahedral, its shape is pyramidal, right? So that is why we call it a pyramidal shape of trimethylamine, or any methyl will have pyramidal shape, but the geometry will be tetrahedral. Okay, guys? Okay, everybody? Non-planar structure. Very good. It is a non-planar structure. Now, next thing is classification. If you talk about the classifications here, in the classification, you have this ammonia, right? Now, when you replace 1 hydrogen, this is 1 degree. When you replace 2 hydrogen, it is 2 degree. You replace 3 hydrogen, it is 3 degree. But when you replace 3 hydrogen and also 1 lone pair, for example, this is your NR, R and R, and here you have the lone pair. Now again what is happening, you are adding 1 more alkyl group, so it will form a coordinate bond with this one, and that is why this will have, nitrogen will have a positive charge. Because of the 4 alkyl group, it is called quaternary, right? It is called quaternary ammonium ion, right? And this positive is on the nitrogen, right? This positive is on the nitrogen, right? Okay, this positive is not on this R, rather it is on this nitrogen. Okay, so that is your quaternary amine, right? Now let us see the preparation of amines, how to prepare amines, right? So starting with the first preparation, that is reduction of nitro compounds, right? So if you have nitro, you have NO2 group, you want to reduce it to NH2. Because why reduction? Because we are taking out oxygen and adding hydrogen to it. That means definitely we are doing the reduction. And there is specific reduction that we do. So basically, first is when we use catalytic hydrogenation in presence of a very good catalyst like nickel, PD, PT, any catalyst you can use in the presence of ethanol, right? So these reactions now, so you will say, ma'am, I can ignore it. No, trust me, the same reactions are asked in JEE Advanced, right? Not directly, but in a sequence of reactions, right? Maybe in one question, you will see around 10 reactions will be there in JEE Advanced. That is the difference, right? So it's not like you can ignore this reaction. These reactions are very, very important. They are very simple, but they are very important for you, right? So here NO2 group is reduced to NH2 group by the catalytic hydrogenation, or you can also use tin HCl or FeHCl, right? This we have already done in Stephen's reduction, if you remember. Do you remember this we have already done in Stephen's reduction? Do you remember that? In Stephen's reduction, we have already used tin plus HCl, Fe plus HCl, right? Okay, so there I also told you that Fe plus HCl, right? So basically this is more valuable, right? If you have a choice that do you want to use a metal, right? Basically it's metal in the presence of acid, right? Metal that we are using here is tin or iron. But which is, the question is asked that which is better, using iron or tin? Which is better for you? So using iron is better for you, Reason I will tell you, but using iron is better for you. Now let us see why using iron is better for you in this case, right? So basically what will happen? Yes. So basically what will happen? In this case, when you use iron plus HCl, it will form FeCl2, right? And in the presence of water, what it will do? It will form again HCl, right? In the presence of water, it will again form HCl here. Now, this HCl is the initial product of this reaction, because what we are using, the reagent is also HCl. And after this reaction also, you are getting HCl. That means HCl is used just for the initiation purpose. We don't have to give this like too much of HCl to this reaction. This reaction will go on because it is going to produce HCl on its own, which is going to restart the reaction again and again, right? So reduction of Fe scrap in HCl is preferred because FeCl2 formed get hydrolyzed to release HCl during the reaction. So very less amount of HCl is required to initiate the reaction, and hence commercially, right, economically, it is more valuable to us, right? Okay, hence it is more valuable to us. Now that was the first reaction. The second reaction here we have is ammonolysis, right? Ammonolysis, or they can also tell you the alkylation process of ammonia, or this is called ammonolysis process, right? So in ammonolysis process, what you can see, everybody, right? In ammonolysis process, what you can see, in ammonolysis process, right, breaking of CX bond. So basically what you will have RX plus you will have ammonia, right? This thing you will have. So this bond will break, this bond will break, right? This bond will break here, right? And this R will get attached to this ammonia. This R will get attached to this ammonia, NH2, and this H will get attached to this one. So you will have the, what will be released here? HX will be released. Again, if you add one more RX here, then again you will have R2NH. Basically, wait a minute. Let me write down on the next page. Let us see, this is R-X plus NH3, right? What you will have, right? What you will have, this is R only because initially you have only one R, right? This R, we know that this is partially positive, this is partially negative, and this nitrogen is partially negative, hydrogen is partially positive. That is why to this negative, this positive will link, and you will have the release of HX here, and you will have the formation of which thing? Because this R will be replaced by one hydrogen here, hence you will have RNH2, right? After that, again we are saying that we are adding RX. Again we are adding RX here. That means excess of RX is added, right? Now again what will happen? You will have the release of HX, and one more hydrogen is replaced by this R. So the answer will be R2NH, right? Again what you will do? You will again add RX here. Then again what will happen? The release of H and X will happen, right? Minus HX, and this R is replaced by this hydrogen, right? So hence you will have R3N. Now I am saying that one more, which you have, one more RX you are adding. That means excess of RX you have, right? So again what will happen? Now we don't have any hydrogen, so there is no release of HX. But what will happen? You have the lone pairs here, right? So this part, this R part will get linked to this part, right? So it will be N, you will have 3R, not 4R, because one, this to this lone pair, this R part will attack over here. You will have this R here because it has 4 bonds here. Nitrogen which have 4 bonds is having positive charge, and to this you will have X negative, right? This thing will be formed, that is your quaternary ammonium salt, right? Okay, so what we have, firstly we have 1 degree amine, then we had 2 degree amine, then we had 3 degree amine, then we had quaternary ammonium salt, right? So this is ammonolysis, in which to the alkyl halide you are adding ammonia. When to the alkyl halide you are adding ammonia, you have the formation of mixture of products, 1 degree, 2 degree, 3 degree and quaternary ammonium salt. That is the reason this reaction is not preferred, right? Because you have a mixture of products that are formed here, right? Okay, so you have a mixture of products that are formed here, as you can see this reaction here. Nucleophilic attack of NHE, that was the overall reaction. Now let us see what will happen here. Nucleophilic attack of NH3 on alkyl halide, right? To the alkyl halide, you will have NH3, right? It will attack on this one, right? Nucleophile. Nucleophile means which is nucleus loving, and itself it has a more electron density. So it has a more electron density, it will attack on the partially positive side of this alkyl halide. This is partially positive, this is partially negative. Hence, this lone pair will attack here, and with the help of SN1 or SN2, there is no formation of carbocation here. This is SN2 mechanism, right? With the help of SN2 mechanism, where transition state is formed, and from that you have the formation of SN, substituted ammonium salt. After this X will leave and you will have HX will leave and you will have the formation of RNH2. Again you add RX, then you will have 2 degree amine. Then again you add RX, you will have the formation of 3 degree. Then again you add it, you will have the formation of quaternary ammonium salt, right? Okay, okay guys. Yes everybody. Now let us see ammonolysis of alkyl halide. As we have, the free amine can be obtained from ammonium salt by treatment with a strong base, right? Now they are saying, for example, you have 1 degree amine, right? That was formed, the substituted ammonium salt that was formed. This is positive and this is negative. Now if you react this with base, then you will have the formation of free amine, right? It will not have any H positive or X negative, right? You will have the formation of free amine. What is the disadvantage of this one? Disadvantage is yielding mixture of primary, secondary, tertiary, quaternary, right? That is why you don't have pure primary cannot be obtained. But if you want to obtain pure primary, right, then what you need to do can be obtained a major product by taking large amount of ammonia, right? See, it's naturally in this reaction what we can see, you have excess of RX, 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 RX. If Rx is in excess, then obviously it will have a mixture of products. But if Rx is limited to you and ammonia is in excess, then definitely it will stop. Chances are it will stop to 1 degree, that is primary amine only. But for that you need to have excess of ammonia here, right? The order, so that all the alkyl halide that you have added will convert that ammonia to 1 degree amine, right? That is the reason for having excess of ammonia. The order of reactivity. Now, order of reactivity, whenever you will have alkyl group throughout this organic chemistry, always it will have this one. If you have alkyl halide or hydrogen halide, always this is going to be the order. Reason is you have fluorine, chlorine, bromine and iodine. Now tell me, from periodic classification down the group, what happens? Size decreases or increases? Down the group size definitely increases, right? So size will increase down the group, right? Because the size is increasing, that is why bond length is increasing. That is the reason it is easy to break that bond. That is why more easy it is to break the bond of R and I or R and halogen. More reactive it will be, because in the mechanism, as you can see, what we are doing, we are breaking this bond only. So more easy it is to break the bond of carbon and halogen, more reactive it will be. That is why this will become the reactivity order. Okay, that is why this will become the reactivity order. So these are the few things that you need to remember for the questions, right? Okay, now next is Mendeus reaction. Now guys, next third reaction is Mendeus reaction or reduction, right? Now in Mendeus, what we have done till now, we have done two reactions. One was reduction, right, with tin or iron acid, or with catalytic hydrogenation. These are the two reductions that we did. Now we are doing the third thing, right? So here what we are using, We are using hydrogen in presence of the catalyst nickel, but along with that, we are using something more, right? That means we are using sodium amalgam, right? Sodium amalgam, right? Sodium amalgam, not zinc amalgam. Sodium amalgam, amalgam means mercury, right? When in the mixture of mercury that you use, that is called amalgam. Sodium amalgam in the presence of ethanol. Now what is going to happen? You have nitrile, right? You have C triple bond N, that will be converted to, basically in this triple bond we know that two are pi bonds, right? 1 sigma 2 pi. Pi bonds are not very strong, right? They have sideways overlapping, they are not strong at all, right? That is why the pi bonds will break, and hence you will have the addition of H2 over here. That is why CH2NH2, it will be converted to that thing, right? That is called adding the hydrogen to the nitrile in the presence of catalyst nickel, but also you will use sodium amalgam along with ethanol. Only then this reaction will occur, right? Okay, so this reaction now, nitriles on reduction with lithium aluminium hydride or catalytic hydrogenation produces primary amines, right? Okay, so this reaction is used for ascent amine series. Now, what do you mean by that? See, here what you have, the alkyl group is R, but here the alkyl group is R plus 1 carbon more. That means the number of carbon in that alkyl chain are increasing. That is the ascending. Ascending means increasing. The number of carbon are increasing. This reaction is used for ascent amine series, preparation of amines containing 1 carbon atom more than the starting amine. Understood? So if in any conversion reactions you want to convert something into something and you want to increase 1 more carbon, right? What you will do? First, you will convert that thing into nitrile, right? Then there will be Mendeus reduction. After that, this will be converted to 1 carbon more alkyl group, right? Okay, then you can do anything with this NH2 group. There are so many reactions of this NH2 group that we will study today, right? Okay, now next is preparation from amides, right? If you have amides, what you need to do? So there are 2 reactions. See, very important. You have 2 reactions, right? In this reaction, the number of carbon atoms, right, throughout this compound are same. Can you see that it has R plus 1 carbon? This is R plus 1 carbon. That I'm not talking about the alkyl chain. I am saying the number of carbon atoms throughout this chain is same, right? Throughout this compound is same, right? So what is happening? We are just replacing this oxygen with 2 hydrogen. This is what we are doing. That is how we are converting. So basically what we are doing, we are adding the amides on reduction with lithium aluminium hydride yields amine, right? Okay, that will add hydrogens in comparison to double bond oxygen, and hence you will have the formation of CH2NH2. This is the amine that you will get, right? So there is one more reaction that we will study, that is Hofmann bromide degradation. In that, with the help of Hofmann bromide, you will have the formation of RNH2, right? So don't get confused in that, right? If they are saying you need to just eliminate this CO, then you should use Hofmann bromide. That we will study. Mechanism also we will study. But if you talk about, ma'am, we want to see the reaction where this CO bond is just reduced, it is not eliminated from the compound, then we will use lithium aluminium hydride. Okay, so there are 2 reactions, don't get confused in that. Okay, I'm writing here, this is Hofmann bromide Hofmann degradation, right? Degradation. Okay, yes. Hello, Resham. Now, let us see the next one, reduction of azide, right? Azide and azo, right? Let us see what are these things. So, azide means when you have N3, right? Azo means you have N2, right? So, azide means you have N3, sodium azide means you have Na positive, N3 negative, because N3 negative it is, right? So, with Na positive, you will have the formation of NaN3, right? That is called sodium azide. So now when you want to reduce the sodium azide, what thing will be formed? You have azide here, you have alkyl halide, that can be 1 degree or 2 degree. Reason what will happen here? Now see what will happen here. This Na will be replaced by the R that you have here, right? And hence you will have RN3, that is called alkyl azide you will have. After this, on adding, or you can say on reducing this particular thing, and after the hydrolysis, you will get RNH2, right? You will get RNH2. That means 2 nitrogens are replaced by the hydrogens, right? The mechanism is not there in your syllabus. That is why I'm not doing that, right? Just simply you need to understand this thing, that if somewhere they have mentioned azide, right? Azide will be replaced by the alkyl group. After that, this alkyl azide on the reduction after the hydrolysis will be converted to 1 degree amine, right? That will be converted to 1 degree amine, right? Okay. Okay, guys. So these are the small reactions that are in your syllabus. But now we are going to do this reaction, that is actually the mechanism is also in your syllabus, right? Okay, this is a very important reaction. Okay. Okay, everybody. You guys are so silent, no? Are you on some Bon Vrat or something? Yes, guys. Sometimes I feel you guys are not even interested. Let me see. Okay, so now a very important reaction. Say something, guys, say something, right? Trust me on that. I can't teach like this, right? I teach on NEET, the students are not like that. I teach on Karnataka, the students are not like that, right? So be active in the chat box, right? This is not what I expect from engineering students. I am also from your background only, right? So this is not what I expect from the engineering students. I have a lot of friends who are very good engineers, and engineers are definitely not like this, right? Okay, glitching, is this glitching? Is there any glitch here? Session, this, ma'am, please. Okay, guys, firstly, my target is to complete this syllabus. We are just left with one more chapter. After that, your previous year questions only I'm going to do, right? Okay. Video delays, ma'am. Now is it fine? Hanji. Now let us see what is Gabriel phthalamide reaction. Now, if you talk about Gabriel phthalamide reaction, in the last lecture I told you what is Gabriel phthalamide. This is basically phthalamide, right? This we have seen in aldehyde ketones as well, right? How to prepare phthalamide. So once you prepare phthalamide, on adding KOH, RX, aqueous NaOH and water hydrolysis, you will get primary amines. And in Gabriel phthalamide, you only get primary amines. You can't get secondary, you can't get tertiary, and this question also has been asked in your JEE 2024, right? So this is a very important question, but the way they have asked the question was very different, right? Okay, so now let us see what is the mechanism. To understand and to give the answer to the question from this particular reaction, you need to know the mechanism here, right? If you don't know the mechanism, directly you know that it will give one primary amines, then you won't be able to answer the level of JEE that they ask, right? Okay, so let us see the mechanism here. Let us see the mechanism here. So basically what will happen? Wait a minute. Let me see if I can. Okay, I can't. I think I can, yes. Okay, so now you have, this is your full-fledged mechanism. Now let us see what will happen. Firstly, when you add KOH into it, then this is this is basically, wait a minute, this nitrogen, this is negative, this is positive, right? Because in comparison to nitrogen, this is more partially positive, this is partially negative. That is why this is partially positive, this is partially negative. So this positive will replace this positive and you will have the placement of K positive over here, right? Once you have K positive, then you are going to react this with alkyl halide, right? Okay, and with the SN2 mechanism, what is SN2? That means transition state, no carbocation will be formed here. Simply what will happen, this is partially positive, this is partially negative. It is going to attack on this one and this K positive is going to leave, right? And hence you will have the formation of NR here, right? Okay, you will have the formation of NR here. Now, this is called N-alkyl because on this nitrogen, you have the alkyl group, right? Now, next step is very important, that once you have this thing, again, you are going to add NaOH in aqueous medium, right? In aqueous medium, now what will happen? Let us see. Now, this bond will break, this bond will break, right? And you will have the addition of this hydrogen and hydrogen over here, right? And here you will have the addition of ONA, and here you will have the addition of ONA, and here you will have the addition of H, and this is H. That is how you will get RNH2, right? Because this bond is going to break, right? This bond will break, this bond will break, and this is RNH2, right? And after this, here you will have COONA, COONA, right? This is what you will get from here, right? This is what you will get from here. Now, why always primary amine? Because you can see that two sigma bonds are already bonded to this carbon. So, there is no scope of adding one more R group here. So, when you add NaOH aqueous, it will definitely break this bond and it will give you two hydrogens here. That is why only primary amines are formed in this case. In Gabriel phthalamide, no 2 degree, no 3 degree amines are formed, prepared from this reaction. Okay. Yes, no 2 degree, no 3 degree, only primary amines are formed from here, right? Next, very, very important reaction is Hofmann bromide degradation that I was talking about. Now, Gabriel phthalamide, Hofmann bromide, these two are most important reactions of this chapter, right? No doubt all the reactions you will see, even the small reactions are important for your JEE, right? Now, let us see. First is preparation of primary amines by treating an amide with bromine in the aqueous or ethanolic solution of sodium hydroxide. So, what they are doing here? You have amide, right? You're adding Br2 in presence of NaOH, right? What will happen here? This whole CO bond will be eliminated and you will have the formation of, this is plus, you will have the formation of RNH2, right? Okay, you will have the formation of RNH2. It is not specified that this will be primary only, secondary only. There is no specification related to that, right? Any kind of amine can be formed here. So let us see the mechanism here. Now here one step is very important, right? There is one step which is very, very important when it comes to Hofmann bromide degradation, right? Because there is internal exchange, right? So you'll see what kind of internal exchange you will see here. Okay. Yes, Yamini, Navadeep, Shri, Vatsa. Yes. Now, what we are going to do here, let us see. So this is your mechanism. Let us see one by one what is the step. So this is RCONH2. This is your amide group. And here you are adding O negative. OH, basically you are adding base here. What is the work of a base? Everybody, what a base does? Base has two things. Either it can behave as a base, it can abstract the alpha hydrogens from there, right? The hydrogen that can easily be eliminated from here. As you can see here, this is the base. Base is going to take out, it will accept the protons here, right? Then when it will accept the proton here, proton will leave from this side. This bond will shift here, this pi electrons, this electrons will shift as pi electrons. and this double bond of carbonyl is going to shift over the oxygen, right? Hence you will have O negative and a double bond is formed here, right? Now is the case of Br2. We have used what is the use of NaOH, right? Again we will use what is NaOH, right? Base, what it has done, this is alpha, this is alpha. From here it has taken out the hydrogens because this is actually lone pairs, this is NH2, right? These hydrogens can easily get like out of this system, right? So that is why this base is attacking on the protons here, and hence you will have the base will accept the proton from here, and hence you will have this thing, right? Now you are adding Br2. From Br2, right, we know that in the end there is no Br2 in the product, right? So what is the use of this Br2, right? Br2, what it will do, wait a minute, yes, Br2, what it will do, these are the pi electron, this is O negative. Oxygen, what it will do, oxygen will again have the pi electrons back, right? And this pi electron, the pi electrons over here are going to make the, see, we know that this Br and this Br both have, so both are having same charge, right? There is no electronegativity difference. But if someone, right, these pi electrons make them have a difference in the dipoles, then we can have one as Br positive, one as Br negative. This is what we are doing here, that these pi electrons will attack on the bromine, right? And hence this bromine will have these pi electrons. That is why this bromine has nothing to do with the electrons of this Br bond. That is why Br negative will leave as, right, will take these electrons and will leave, right? Now you have the attachment of this Br on this nitrogen, right? You have the attachment of this Br because it is taking away the electrons. This Br is taking away the electrons. It is eliminating as Br negative is being eliminated from here. Right now this Br is attacking on this nitrogen. It has attached to this nitrogen, and hence you have this thing. Even now we have no scope what is happening, ma'am. That is why it is one of the most difficult and one of the most important mechanisms of organic chemistry, right, in your syllabus, obviously, right? So now again, because we have added excess of this OH, now again what will happen, because in this nitrogen you had two hydrogens, now the base will attack on the other proton and it will take out the H positive from here, right? Then again these electrons will shift here, the oxygen will take the O negative, right? Again the same thing is going to happen, right? Now what is going to happen, this is what you have. Now these two steps are very important, right? These two steps are very important, that what will happen, internal exchange will happen, right? Can you see this? Basically this is RnCO, this is RCnBr, right? So what is happening here? Firstly, Br negative will be eliminated as electrons. These electrons will jump here. Now this alkyl group, right, this whole alkyl group will get attached to the nitrogen. This is very important, right? That this whole alkyl group, wait a minute, yes. So this whole alkyl group will get attached to the nitrogen here. And hence you will have the formation of RnCO, right? This is a very, very, very important compound. You have the formation of RnCO, right? But in this, what you had the attachment of RCN. So that is what is happening. Internal transfer of the alkyl group is happening here. That because of this step, this reaction is very important. And from this step, the questions can be asked, right? Okay. So internal transfer is happening. This R group is shifting to this nitrogen, right? And hence this is Rn. Again, it is double bond carbon. Now this double bond has shifted, this electrons has shifted on the CO bond. So it is double bond O. So it is Rn double bond C double bond O, right? Okay. After that, you add water into it. Then this bond will break and hence you will have the formation of CO2 will release and you will have addition of 2 hydrogens here, and this is RNH2 will be formed. Okay, yes everybody, yes everybody, which is the most important step here? This is the most important step, right? That alkyl group is internally transferred to the nitrogen here, right? Okay, yes. Yes, Anandu, no issues. Everybody, are you able to understand this? What happened here? Base first, it will take out the proton. Then obviously there will be arrangement of electrons here, rearrangement of electrons. These sigma electrons will shift here as pi electrons. The pi electrons will shift here, right, on the oxygen. Again, the oxygen wants to have the pi electron bond back to the bonded state. And these pi electrons, because we can't have pentavalent carbon, that is why this pi electrons will attack on the Br2, right? Here you will have the elimination of Br and you will have the attachment of Br here. Again, the base will abstract one proton from here and pi electrons will shift here, pi electrons will shift here. This is the thing that you will have. After this, there will be shifting of this alkyl group, shifting of this alkyl group. There will be shifting of this alkyl group, right? This is the alkyl group that will be shifted to this nitrogen, and hence you will have RNC double bond O and Br will be eliminated from here, right? Okay, yes. Yes, directly they will not ask you the mechanisms, but yes, any step can be asked from here, especially this step, right? Okay, and this is called Hofmann bromide degradation reaction. Okay, this is called Hofmann bromide degradation reaction. Next are the physical properties of amines, right? Okay, so shall we talk about physical properties of amines? Simple, simple, simple. If you talk about the physical properties of amines, first is solubility, right? First is solubility. We know that amines have nitrogen, right? Nitrogen obviously form hydrogen bond with water, right? So if you talk about the solubility, they are soluble in water, right? Lower aliphatic amines are soluble in water. Why? Because if you talk about this RNH2, right? If R group is small, then the hydrogen bonding will be more, right? We know that here you will have one hydrogen, you will have one hydrogen, right? This hydrogen can obviously have hydrogen bond. This hydrogen can obviously have hydrogen bond with the oxygen or water, right? This is water. This nitrogen can have hydrogen bond with the hydrogen or water, right? So basically 1 degree amine can form 3 hydrogen bonds in water. If you talk about 2 degree amines, if I have 2 degree amines, then obviously with 2 degree amines, I will have this thing, right? With 2 degree amines, there will be R. So there will be only 2 hydrogen bonds. With 3 degree amines, obviously there will be one more R. So there will be only one degree amine. There will be only one hydrogen bond. That is the reason 1 degree amines are more soluble than 2 degree. Then you have 3 degree amines, right? Then you have 3 degree amines, right? Now, if you talk about the solubility, lower aliphatic amines are soluble in water as they can form hydrogen bond with water. So lower is the mass of the alkyl chain. So for example, I have RNH2. Now this alkyl chain is really big. Now it will be very difficult for this nitrogen and these two hydrogen to form the hydrogen bond because of the steric repulsion, steric hindrance. That is why lower is the molar mass of this alkyl group, more is the solubility, right? Next is, however, solubility decreases on increase in molar mass. As we increase the molar mass because of the steric hindrance, solubility is going to decrease. Increase in the mass of aliphatic part, which is hydrophobic in nature. Now, if you talk about the solubility also, that is more in 1 degree, then 2 degree, then 3 degree. Now, let us talk about the second concept, that is boiling point. Boiling point means to break the forces of attraction. So, more are the force of attraction, more will be the boiling point. So we know that if you talk about 1 degree amine, so this is 1 degree amine, it has, if you talk about the interaction with itself, right? In solubility, we talk about the interactions with water. Here we are going to talk about the interaction with its own molecules, right? So this is one primary amine, this is one primary amine. Now, this primary amine, wait a minute, this is RNH2, no, this is actually hydrogen bonding only, right? Okay, so this primary amine is hydrogen bonded to this other hydrogen. This hydrogen is another hydrogen bonded to another hydrogen. It is also having one more hydrogen bonding. So wait a minute, let me show you. If you have primary, right, you have R, N, H, H, right? We know that it will have hydrogen bonding, it will have hydrogen bonding, it will have hydrogen bonding. So basically one molecule is forming 3 hydrogen bonds. If you talk about 2 degree amine, so this is R, this is N, this is R, this is H. So now it will have 2 hydrogen bonding, this and this. These are the 2 hydrogen bondings that it will have. If you talk about 3 degree, it will have, this is N, this is R, this is R, this is R. Now it will have only 1 hydrogen bonding. We know that more is the hydrogen bonding, more is the interactions. So more will be the boiling point. That is why this is 1 degree, this is 2 degree, that is 3 degree. That is why 1 degree has more boiling point as compared to 2 degree, as compared to 3 degree. And hence this is the order of the boiling point that you have. This is the order of the boiling point, right? Okay. So primary, secondary involves intermolecular hydrogen bonding between nitrogen of one and hydrogen of other. Oh wait, tertiary to will not show any hydrogen bonding. Reason. Because see, for the other molecule also we require hydrogen. In tertiary, there is no hydrogen in any molecule. So this nitrogen can show hydrogen bonding, but it needs some other hydrogen, right? It does not have any hydrogen in any molecule of tertiary amine. That is why there is no hydrogen bonding. No hydrogen bonding here. Because see, it can show hydrogen bonding with nitrogen. It can show hydrogen bonding with hydrogen. It is with nitrogen. This is with hydrogen. This is with nitrogen. It can show hydrogen bonding with the hydrogen, but there is no hydrogen in any molecule. That is why there is no hydrogen bonding, right? Okay, Sindhuja, hello. Very happy to know that. So I hope so you are able to clear all the concepts here, right? So that is why 1 degree, then 2 degree, then 3 degree, right? Now let us talk about the most important topic, that is basic character, right? What about the basic character of amines, right? Firstly, we will talk about general gaseous phase, right? Then we will talk about the aqueous phase, right? And for basic character, basically acidity and basicity, it is a very vast topic and it is usually asked, right? That is linked to the GOC, right? So if you want me to cover GOC also on this channel, then do let me know, because there are acidic and basic stabilities, intermediate stabilities, acid and basic character based on GOC only, right? So that I will cover in that particular lecture only. But if you talk about the basic character specific to amines, then what we can say? So if you talk about amines here, amines are basic like ammonia only, they are basic in nature. But if you talk about 1 degree, 2 degree, 3 degree amines, this is 1 degree amine that I am making. This is in the gaseous phase, okay? This is not in the aqueous phase. This is in the gaseous phase. This is 2 degree, right? And this is 3 degree. And this is 3 degree. Now, what is basicity? For that, you need to understand what is basically basicity, right? Basicity is directly proportional to electron donating group and inversely to electron withdrawing group, right? Or we can also say that it is directly proportional to the number, or you can say it is directly proportional to the availability of electrons or lone pairs. Lone pairs, you can say the availability of lone pairs. So more is the availability of lone pairs, that means more is the electron density, more basic it will be, right? That is why we are saying more is the electron donation, more basic it will be, right? So let us see here, this is 1 degree, this is 2 degree, and this is 3 degree. From here we can easily see that alkyl groups are electron donating species. They have plus I effect, isn't it? They have plus I effect. So they will give you plus I effect from here, right? So plus I effect, this alkyl, hydrogen will not show any plus I effect, alkyl will show. Here you have 2 alkyl groups, so 2 plus I effects are shown here. Here you have 3 alkyl groups, so 3 plus I effects are shown here. Now tell me electron density, because already it has one lone pair over here, right? So to this lone pair, you are providing from one side, you are providing from two sides, you are providing from 3 sides. Now this nitrogen will be richest among them. That means it will have the maximum electron density. More is the electron density, more is the basic character. That is why we can say that tertiary amines in the gaseous phase, okay? Always remember, all the things that I am talking about here is in the gaseous phase, in the gaseous phase, right? So in the gaseous phase, we have 3 degree, then we have 2 degree, then we have 1 degree. That is the basic character, basic strength, okay? That is the basic strength here, right? That is the basic strength here. Understood why I am mentioning gaseous again? Because in so now let us talk about, this is the gaseous phase only that we are talking about, that in gaseous phase it will remain the same, but in aqueous phase things will change, right? There is a specific reason for that, right? Alkylamines 1 degree, 2 degree, 3 degree are strong bases that is affected by inductive effect, as I told you, of the alkyl group. That is why, because of this plus I effect, alkylamines can donate lone pairs of electron more easily than ammonia, right? If you talk about as compared to ammonia, ammonia will be least here. Why? Because there is no electron donation from any alkyl group. That is why it is least basic among them, right? So here we can say that the basic character is first is 3 degree, then 2 degree, then 1 degree, then ammonia, but this is in the gaseous phase, that is non-polar. It's not non-planar, it's non-polar, right? Non-polar medium, right? Now, if we are adding here, wait a minute, definitely extra we have, right? So, when we talk about the gaseous phase, right, there is no water. But when we talk about polar medium, that means we are adding water into it, right? So there will be 2-3 more cases that will affect, right? First is the hydrogen bonding with water, the steric hindrance, the solvation, right? So all these things will affect the basic character, right? So let us talk about the aqueous medium, what will happen. So in aqueous medium, firstly, I will give you the answer only. Then we will talk about the reasons. Firstly, I will give you the answer here, right? In aqueous medium, you can write here that in aqueous medium, what you will have? Any idea, guys? Any idea? In aqueous medium, if you have R group as methyl, that means you have CH3. Chalo, I'll write it here only, right? That means you have 1 degree, 2 degree, 3 degree amines, but R alkyl group is methyl. In that case, answer will be 2 degree, then you will have 1 degree, then you will have 3 degree, right? That is going to be the answer. But if we talk about, you have R is equals to ethyl. In that case, it will be 2 degree, then 3 degree, then 1 degree. That is going to be the answer, right? Okay. Now I know you are still confused, ma'am, why this is so. Ma'am, why in aqueous medium things are very different? So because of first is inductance, first is inductive effect, second is steric hindrance, third is solvation. So that is our motto. That why, as I told you, here the answer is 213, here answer is 231. Right, that is the answer here. Now why it is so? Why it is not 3, 2, 1 that we have discussed in gaseous phase? Why it is different? Because of these two other factors that are included here. So let us see what are these two other factors and why it is so. Right, so let us study that. Right. So here, yes, here as you can see, in the aqueous phase, right, they are saying extent of hydrogen bonding in water, order of stability of ions by solvation. As I told you, there is one more inductive effect that we have seen. According to inductive effect, 3 degree has maximum, then you have 2 degree, then you have 1 degree. This is according to the inductive effect, right? This is according to the inductive effect. Now, if we talk about the extent of hydrogen bonding in case of solvation, just give me a second. So, if you talk about the solvation energy here, what about the solvation energy? Very simple. Now, solvation energy means with hydrogen, how much, with water, how much hydrogen bonding it is forming, right? So if you talk about amines, right, so basically it will be forming how much hydrogen bonding? Firstly, with this hydrogen it is forming hydrogen bond, with this hydrogen it is forming hydrogen bond, then in the hydration, in the water, those lone pairs on the nitrogen, they will accept the hydrogen and they will become this thing. They will become ion here. That is why it is N positive H here. Now this hydrogen is also showing one more hydrogen bonding, right? Hydrogen bonding is maximum in this case, right? Then here it is showing 2 hydrogen bondings, right? Here it is showing 1 hydrogen bonding. You will say, ma'am, tertiary, so it will not show any hydrogen bonding. I am saying that it is in the aqueous medium. In the aqueous medium, when it accepts H positive from water, it will have 1 H, and to that hydrogen it is forming hydrogen bonding, right? So basically, if you talk about the hydrogen bonding, right, it is maximum in 1 degree, then 2 degree, then 3 degree. That means the solvation energy means to break these bonds, Here it has to break 3 bonds. Here it has to break 2 bonds. Here it has to break only 1 bond. That means the solvation energy will be maximum in case of 1 degree, then 2 degree, then 3 degree, right? That is the case for solvation energy. More is the solvation energy, more better it will be. So extent of hydrogen bonding in water and order of stability of ions by solvation is this one, right? So 2 orders we are already getting, that by steric hindrance this is the case, by solvation energy this is the case, that is 1 degree, 2 degree, 3 degree. That was not there in gaseous medium, right? Now third thing is steric hindrance, right? Third thing is steric hindrance. Now let us talk about the steric hindrance. If you talk about the steric hindrance here, right? If you talk about the steric hindrance only, they are talking, yes. If you talk about the steric hindrance here, as you can see, in 1 degree, there is 1 methyl group, right? In 2 degree, there are 2 methyl group. In 3 degree, there are 3 methyl groups. That is why steric hindrance is maximum in tertiary, then secondary, then primary. So can I write it here? Steric hindrance is maximum 3 degree, then 2 degree, then 1 degree. Basic character is, for inductive effect, it is like this. For solvation energy, it is like this. So these are the 3 general order that we got, right? Solvation energy is maximum in 1 degree. Inductive effect is maximum in 3 degree. Steric hindrance is maximum in 3 degree, right? So these are the three things. More is the steric hindrance. Now tell me one thing. If it is very crowded and these lone pairs wants to accept some other hydrogen or anything from outside, then if there is more steric hindrance, it will be difficult for them to accept it. That means steric hindrance is opposite to the basicity. More is the steric hindrance, lesser will be the basicity. So in conclusion to these three effects, right, in conclusion to these three effects we will have, here they have written everything, that when we talk about methyl group obviously 1 degree will have minimum plus I effect. It will have maximum solvation because of more hydrogen bond. It will have less steric hindrance. That is why the attack of some other atom on the lone pair is easy, right? 2 degree will have moderate plus I, moderate solvation, moderate steric hindrance. 3 degree will have more plus I, less solvation, more steric hindrance. Because of the combined effect of these three things, we have our order as this one. In aqueous medium, very, very important. In aqueous medium, it is methyl substituted amines. Just remember 2, 3, 1. Here it is 2, 1. Wait a minute. 2, 1, 3. It is 2, 3, 1. Just remember this thing. That means 2 degree, then 1 degree, then 3 degree, then ammonia will be last always. Right? Here it is 2 degree, then 3 degree, then 1 degree, then you have ammonia. Right? Okay? That is the combined effect of these three cases. Right? Okay? That is the combined effect of these three cases. Right, guys? Everybody? Is that clear? Is that clear or not? Is that clear? Now, let us talk about one more thing here. That is, ammonia is basic than aniline. Now, let us talk about this statement here. When we talk about ammonia, it is NH3. When we talk about aniline, it is this thing. These are the lone pairs on the aniline. We know that what will happen in case of aniline, the lone pairs will be donated here, pi electrons will be shifted here. So basically, the availability of lone pair is decreasing, isn't it? On nitrogen, the availability of lone pair is decreasing. That means this lone pair is delocalized. This lone pair is delocalized and this lone pair is localized. This lone pair is localized. It is staying in that position. For example, you have a friend who never stays at his home, right? So you're always going here and there, roaming around, right? But this is a very, very Saw Sharif friend who is always staying at his home, right? So now the one friend who is staying at his home, who is localized, who is always available for you, that will be more basic, right? That is why ammonia is more basic as compared to aniline, right? That is why ammonia is more basic as compared to aniline. Unshared electron of aniline is less available due to the resonance, right? Okay, got it? This is the resonating structure as you can see, right? The resonating structure is, it is revolving. Firstly, on ortho position, you will have one negative. Then electrons will jump here. Pi electrons will jump on the para position. Electrons over here. Then these electrons will jump and here it will form a pi bond. Pi electrons will jump and form a negative charge here. Then again, negative charge will be pi bond here. Then these pi electrons will jump back to the nitrogen and you will have 5 resonating structures here, right? Resonance also is in GOC. If you want me to do GOC, then you can just let me know in the comment section. I'll read your comments and see how many of you want me to do GOC. According to that only I will pick GOC, right? Okay, yes. Because GOC forms, it is everywhere in organic chemistry. You can't skip GOC, right? Okay. Now, let us see effect of substituents on basic character. As I told you, it is directly proportional to electron withdrawing. It is inversely proportional to, it is directly proportional to electron donating. It is inversely proportional to electron withdrawing group, right? Okay. For example, you have this thing, right? You have this thing. In this case, you can easily say that here you have OCH3. Now, how come OCH3 is donating? Because I told you one thing, I have been telling you from the first day I have started teaching on this channel, that if you have a group that has lone pair of electrons, it will donate the lone pairs into the benzene ring, and hence it will show plus M effect here. That means it is electron donating. But if you have a group that does not have lone pair here, but it is double bondedly to some element X, but X is more electron negative as compared to G. So what will happen here? These pi electrons will jump here. These pi electrons will jump here. It will show minus M effect. That is why it is electron withdrawing. Right? So now let us see, because this oxygen already had two lone pairs here. That is why it will show plus M effect. That is why it is electron donating group. Right? Here there is no effect, no group. But this NO2, nitrogen is double bonded to this oxygen. This is positive, this is negative. You have this thing. Now from here we can say that, definitely this nitrogen is less electronegative as compared to oxygen. Oxygen is more electronegative as compared to nitrogen. So this pi bond will be shifted to the oxygen. This pi bond will be shifted here. That means it is showing minus M effect. So you can write here it is showing minus M effect, electron withdrawing group. So that is the reason more is the electron donating, more is the basicity, more is the electron withdrawing, less is the basicity. Hence this will become the order of basicity. Right? Okay. This will become the order of basicity. Okay guys. Yes guys, everybody. Okay. Now next is, okay, there is one more question, right, which will clear your basic, right? Now, for example, you have pyridine, right? And here you have aniline, right? Here you have aniline, right? So if you talk about pyridine, it also has 2 electrons. It also has 2 electrons over here, right? Now you need to tell me which is more basic, which is less basic. What is a basic character? This is pyridine. This is pyridine. This is aniline. This is aniline. Which is more basic in nature? A very, very basic question, right? Everybody, let us see who is able to answer this. Let us see who is able to answer this. Yes, students. Yes, students. I don't know. Yes, guys. Anything that you feel is like more acidic or more basic, right? So here, understand one thing, that in this case, what will happen? Lone pair double bond, right? So that is the reason here the resonance is not due to this lone pair. It is due to the pi electrons only. So the resonance will occur like this. That is why this lone pair is localized in nature. This lone pair is localized in nature. But this lone pair, it will shift here. This pi bond will shift here, right? It will shift throughout. There will be resonance throughout this benzene, right? Throughout this ring. That is the reason this lone pair is delocalized. So when you have a localized lone pair, it will be more basic in nature, right? More is the availability of lone pair, more is the basicity. Hence we say that pyridine is more basic as compared to aniline, right? Okay, understood everybody? Understood everybody in the chat box? Everybody in the chat box, are you able to understand this thing or not? Right? whenever a nitrogen is sp2 hybridized, it is localized. This is a trick that I am giving you, right? But if a nitrogen is sp3 hybridized, right, and it is also connected to a double bond somewhere, then this nitrogen is delocalized. Delocalized. And always localized is more basic as compared to delocalized. Okay? Are bhai, speak something. I can't teach like that. You to make me feel as if I am in some another world only, right? So I should teach the camera only, isn't it? How many of you are actually studying, actually want to study and crack JEE? How many of you are actually interested in that? Let me know in the chat box. I can't give you these kind of looks like daily, right? If you can't interact, then what's the point, guys? What's the point? Yes, Dhanushri. You can try if you're able to understand. I think you guys are not only interested in this. So should I just end the class? Why I'm taking the classes here? Right? Why I'm taking the classes here? Pyrrole. Pyrrole is again, wait a minute. Pyrrole. It is again more, it is again less as compared to pyridine. As compared to pyridine, it is less basic, right? Because these lone pairs are delocalized, right? Okay. Pyrrole is again less basic. So I think I should not see your chats only. I should teach myself only here. No worries. So now next is alkylation. Now we have started the chemical properties. Let us start the reaction of amines. First is alkylation. Alkylation is same as ammonolysis, right? This is ammonolysis only, not same. It is the same reaction. Ammonolysis. It just the name is different, right? Here we are doing the same thing. When we say that we are adding ammonia to alkyl halide, right, that is called ammonolysis. When we say that to a primary amine or ammonia, we are adding alkyl halide, that is called alkylation, right? The thing is same only, right? The reactions are same only. So here to this primary amine, you are adding R-X. So what will happen? This R- will replace the hydrogen here. You will have R-NH. Again, you are adding R-X. Again, one hydrogen will be replaced here. Then again, you add R-X. Again, this not hydrogen, but the lone pair will accept the R- and you will have the formation of quaternary ammonium salt. Right? Okay? Yes, furan, that is furan, but furan is oxygen. Right? Okay? Yes, furan is oxygen. Now, next is reaction of amines. Now, next reaction is acylation reaction. Now, what happens in case of acylation? Basically, acyl group is added here, right? So, aliphatic and aromatic primary secondary amines react with acid chlorides, anhydrides, ester by nucleophilic substitution reaction to form amides, right? Let us see the reaction here. Right, so basically this is the acylation reaction. Let us see what we are doing here, right? So here you have 1 degree amine to which you are adding this CO, CH3Cl and with the base, right? So here what will happen? This lone pair will attack on this. Why? Because this is partially positive, this is partially negative. Then lone pair will attack on the less, that means partially positive, less polar side it will attack. Right, so it will attack on the less polar side and here this is N, this is H, this is H. This will be attached here. Now what will happen? This Cl negative will be replaced here. It will eliminate. The negative charge will jump here, and this, wait a minute, yes. And here what will happen? This H will also be eliminated from this side, right? And this electrons over here will be taken by the nitrogen here as lone pairs, right? Hence, to this nitrogen, you will have one lone pair. You will have one lone pair, one C2H5, one hydrogen. This negative charge is taken by this pi, taken as pi electrons, that is pi bond. So here you will have pi bond here, right? This is C double bond O, and here Cl negative. Cl negative is eliminated basically, so it will be CH3 here, right? So this is called N-ethyl ethanamide, right? Now, after this, for example, now we have another thing. So basically in the end, what is happening? To this hydrogen, you have attached COCH3. That is called acylation. And this we have done in Friedel-Crafts acylation also. Whenever you add COCH3 group, that is called acyl group, right? That whenever you add that, that is called acylation, right? Here also it is the same thing, right? So same thing is happening here. When you have N-hydride, then this COCH3, right? We know that this is partially positive, this is partially negative. Same thing will happen here, and the attack will occur, and hence you will have the formation of COCH3 group in place of hydrogen. That is called acylation. Again, this reaction is also included in the series of reactions that they will ask you in the JEE questions, right? Okay. This reaction is also called benzoylation. Now, what is benzoylation? When you add this group, when this group is added, that is called benzoylation, right? That means, for example, you have CH3NH. So instead of this hydrogen here, you will add a C double bond O, C6H5. That will be called as benzoylation, right? Okay, so basically what you are doing, you have NERN. This is, and to tertiary amines, this cannot happen. Why? If you have tertiary amines, you will have no hydrogen to get replaced. That is the reason you at least need one hydrogen to replace it. If you want to have benzoylation, then C double bond O, C6H5 will be added. If you're talking about acylation, then COCH3 will be added here, right? That is called benzoylation or acylation, right? Okay. This reaction is carried out in presence of base stronger than the amine, like pyridine. Now, can you tell me why pyridine is used here? This question has also been asked, why pyridine is used here, right? Reason why we need a stronger base than pyridine. Why we need a stronger base than pyridine? Anybody? Is why we need a like a stronger base here than this ammonia? Why pyridine is used here? Why pyridine is used here? Anybody in the chat box? Anybody in the chat box? Reason being, we actually want that stronger than the amine, because we want this pyridine, which is more stronger. We don't want this pyridine or this amine to behave as a base, right? If this amine behave as a base, this is a ketonic group, so this is behaving as a base, they will show acid-base reactions. That is why we have used a stronger base here, to avoid that thing here, so that it can behave as a, with the electrons here, it can attack on the carbonyl carbon, right? Okay, that is why we have used pyridine to distract it, right? So that it can feel that this is a stronger base, so that this can feel that this is a stronger base, this is not a base. For that, we have used a stronger base as compared to this amine, right? Now, next one, this is carbylamine reaction. This is also a very good distinguished test of amines, right? So, this is used to distinguish 1 degree amine, that is used to distinguish primary amines only. It is also called isocyanide test, right? It is also called isocyanide test. Its mechanism is also very important, right? It is somewhat little bit similar to Hofmann bromide, not similar, Just one step is similar, right? Aliphatic and aromatic primary amines on heating with chloroform and ethanolic potassium hydroxide, they give isocyanide, basically KOH plus CHCl3, and here you will have the electrophile, that is dichlorocarbene, right? Carbene is acting as the electrophile here, right? So that is also important, that which electrophile. This electrophile is also used, is also made in Remer-Temer reaction, right? So isocyanide are foul smelling substances. That is why from that foul smell, bad smell, we can say that yes, isocyanide is formed, and hence we can say that definitely there was presence of 1 degree or 1 degree aromatic or aliphatic amines, right? Secondary and tertiary amines do not show this reaction. Secondary and tertiary will not show this reaction. This reaction is used as test for primary amines. So now let us see this test. Basically, RNH2 is converted to RNC. That is called isocyanide, right? That is called isocyanide. Okay, so you have CH3NH2 in the presence of base and chloroform. This RNH2 is converted to RNC, right? So now let us see the mechanism here. Mechanism is very important here, right? Mechanism is very important. All the mechanism that I'm telling you that are important are actually very important for you, right? So let us see this here, what is happening, right? Okay guys, let us see what is happening here. So basically you have a base. First step is same as that we did in Remer-Temer reaction. That is the formation of electrophile, that is chlorocarbene, right? So now first thing is the formation of this electrophile, that is dichlorocarbene, right? This step is very important. Same as that, here we know that what is the work of a base. Base wants to abstract proton, right? So base will attack on this H. It will abstract the proton here. The electrons here will jump on this carbon. There will be C negative CCl3, right? So now we know that what will happen from here, you will have in this KOH, you have KOH, right? So OH has done its work. Now you are left with K positive here. K positive, what it will do? It will take out one Cl negative from here, and what you will have? Cl negative will be taken out from here, and you will have the elimination of KCl from here, and this 2 electrons here and 2 electrons here, they will form dichlorocarbene, which has 6 electrons for this carbon, right? Okay, they will form dichlorocarbene will be formed here, right? Okay, yes everybody, yes everybody. Here it should not have 2 electrons, right? Because these 2 electrons are basically 2 electrons. This negative charge is these 2 electrons that we have shown as dichlorocarbene, right? Okay, so that is the formation of this electrophile that is going to attack here. Now you have this ammonia, you have this amine, 1 degree amine, because only 1 degree amine will show this reaction, right? And you have this dichlorocarbene, that is your electrophile. Electrophile means which is electrophile, you can say, which is electron loving, which is electron deficient, right? So it is going towards the electron density. We know that electron density is more on this nitrogen. Now first question that students usually confuse is, right, they say that ma'am, this has 2 electrons, ma'am, this is also lone pair, this is also lone pair, ma'am, if it has lone pairs, then how come it is electron deficient? Guys, let's talk about the octet rule here, very basic rule, right? You tell me one thing here, it has 2 electron, 2 electron and 2 electron, total 6 electron it has. So it is definitely, the octet is not complete, right? It has 6 electrons, it is definitely electron deficient. That is why it wants to have 2 more electrons to complete its octet, right? So it is behaving as an electrophile only, right? Now these lone pairs will attack on this electrophile, right? Definitely in the mechanism, always the arrow will be more electron density to less electron density. So it will be towards this one. They are going to attack here. Now they will form a bond here, right? This is the bond that you will see. Now here you will see internal transfer only, right? Let us see, not internal transfer. Yes, here you don't see the internal transfer. There you see the internal transfer. right? So here what will happen? So this carbon, initially it was having 6 electrons. Now it is having two more electrons as compared to the previous. Now it is having 8 electrons. 2 electrons are shared from these nitrogen. That is why it carries a negative charge here. Very rarely you will see carbon having a negative charge. Here you will see carbon is having a negative charge. Why? Because it is having one more bond with this chlorine. That is why carbon has a negative charge. This nitrogen will have a positive charge because it is forming 2 bonds here. Right? Now, carbon can't have a negative charge. That is why it wants to eliminate that negative charge. Firstly, what will happen? This electron, it will be eliminated, right? So, this Cl will leave from this side. Now, this OH, so basically what will happen? Again, this base is going to abstract the proton, right? H positive will leave from this side. Now, the electrons between this nitrogen and hydrogen, right? They will be shifted towards the nitrogen, which will neutralize the nitrogen, because now nitrogen has which thing? Now nitrogen has only 3 bonds, right? Now the nitrogen has only 3 bonds. And simultaneously, this Cl will be eliminated as Cl negative. So you can draw also this arrow. This will be eliminated as Cl negative. Now in the end, what you will have? This nitrogen is having 1, 2, 3 bonds, right? We know that there is also one more bond, that is, wait a minute, this is having one more pi bond. Yes, it will form a pi bond here, no? That is why this this chlorine is getting eliminated, right? So this is shifted to this side. The electrons are shifted to this NC bond. That is how you will have NC triple bond, right? So these electrons between nitrogen and hydrogen are shifted to this NC bond. You will have a pi bond here. And this carbon cannot handle 4 bond and 1 negative charge. That is why this Cl will be eliminated from this side, right? Now in the end you will have nitrogen having 1 R, having 1 hydrogen, and this is having 1 pi electron here. That is, this is pi bond, this is sigma bond, right? Why nitrogen is having positive? Because nitrogen is having 4 bonds here. Now this C with a negative and 1 Cl, right? Again, what will happen? You will have this OH. OH is going to attack again to this proton, and it will take out this proton. Same reaction will happen, right? Now the bond between this nitrogen and hydrogen is again shifted as pi bond to nitrogen and carbon. Now you have N triple bond C. Now you have this thing, right? Again, because this carbon cannot handle 4 bond and 1 negative charge, so 1 sigma bond will be eliminated as Cl negative, right? Then what you will have? Rn triple bond C, right? You can see Rn triple bond C. Nitrogen is having positive charge, carbon is having negative charge, right? Because carbon is forming only 3 bonds here, that is why 1 negative charge. Nitrogen is having 4 bonds, that is why 1 positive charge. This is called isocyanide, right? Okay, yes guys. Okay guys, everybody, now I think this is clear to you. So basically the same thing is happening again and again, right? Same thing is happening again and again, right? What a base is doing? It is abstracting the proton, and to balance that thing, other electrons are shifting here and there, right? Okay, mechanism, you can just saw that, okay, you can just see this, okay, this is the mechanism, and it's very simple, 1-page mechanism. Actually, someone has given up their life for these mechanisms. Like throughout their life, they have tried and tested, from a multiple reactions, they have got this reaction, right? Okay, what you need to do, you just need to remember this mechanism, right? Okay. Okay, everybody. Okay, everybody. Now, next thing is reaction with nitrous acid, right? So we are basically doing the test to distinguish. First we did is carbylamine test, right? In carbylamine test, you will have the identification of 1 degree primary or primary aromatic or aliphatic amines, right? Nitrous test, what it is going to give you? It is going to differentiate between so many things, mostly aromatic and aliphatic, right? So let us see this. Nitrous means you are adding, this is OR, okay, this is OR. Either they will give you NaNO2 plus HCl or they will give you directly HNO3, because NaNO2 plus HCl will only form HNO3 only, right? So also the temperature should be 0 to 5 degrees Celsius. But for aliphatic, it should not be that much cold. So now let us see what will happen here. See, when you have aliphatic, right, a very basic difference is, when you have aliphatic, if this is, I am saying is aliphatic, right, in that case, when you are adding NaNO2 HCl or HNO2, then what will happen? Definitely you will have the formation of diazonium salt. That is, this NH2 is converted to N2 positive Cl negative. But in this case, it is a very unstable compound. When we talk about, if you have aliphatic amine and diazonium salt is formed by aliphatic amine, this is a very, very unstable salt. Just simply giving it water, not even warming it, I am just giving it water. I am not warming it or anything. I am not providing heat to it, right? It is directly converted to alcohol, right? It is directly converted to alcohol, right? Understood? It is directly converted to alcohol. But if I talk about aromatic, in aromatic, this benzene diazonium chloride is still stable as compared to when this diazonium salt is formed from aliphatic. That means this is still stable. That is why from the benzene diazonium salt you have so many reactions that are important for you. And this is actually one of the most important parts of this chapter, right, from where the questions are asked, right? So this is converted to alcohol. Yes, it is converted to alcohol, but you need to warm it. When you warm it, only then you will have the formation of phenol. It's not like you are just adding water to it, then you will replace this N2Cl with OH. You need to warm it, only then you will have the formation of phenol plus liberation of this N2 gas. So basically nitrous acid test will tell you whether it's aliphatic or aromatic depending upon the liberation of nitrogen gas. If nitrogen gas is liberated as it is, right, directly, and alcohols are formed after that, then we can say it is aliphatic. If nitrogen gas is not liberated, and you can do any other test of, you have to warm it to liberate the nitrogen gas, then it is definitely aromatic in nature, right? Okay, so now we can see this here. You can see this thing here. Nitrous acid test to distinguish between primary, secondary, tertiary amines. This reaction is carried out in situ from mineral acid and sodium nitrite. That means we combine NaNO2 and HCl, right? Primary aliphatic amines react with nitrous acid to form aliphatic diazonium salt, which is unstable and liberate nitrogen gas and alcohols, right? This is a very important point. But if you talk about the diazonium salt that is formed here, is very important class of compound used in synthesis of variety of aromatic compounds, and it is still stable. We can have a lot of different reaction from this one. But if we want to have phenol, then we have to warm it. Only then it will give you phenol plus nitrogen gas, right? Okay. Yes, very good evening, Shruti. Very good evening. Okay, understood? Yes, guys. Next is Cope reaction, right? Very important. It is also a distinguished test. Very, very important. Cope reaction. Basically, it is Cope elimination. It is an elimination reaction. It is a elimination reaction. So in this elimination reaction, firstly, let us see what will happen, right? So we are saying that in the Cope reaction, what if you have tertiary amine oxides having beta hydrogen atom. Tertiary, I'll show you firstly, I'll show you the reaction only. This is the reaction, right? Wait a minute. Wait a minute. Yes. Now, see. Firstly, the identification is you need to have tertiary amines here, right? If you have tertiary amines, this is, we know that this is 3 degree amine only. This is 3 degree amine only, right? So when you add H2O2 peroxide or ozone gas, right, or ozone, right, or Carros acid, right, any of these things can be mentioned to you. Either it's H2O2 or O3 or Carros acid, right? Once you add any of this thing here, the lone pair of this nitrogen will have the bond with oxygen from this H2O2 or O3 or Carros acid, right? Because Carros acid is also a very good oxidizing agent, right? So it is going to give you the oxygen, right? So once you have oxygen from any of this compound, right, that is called as tertiary amine oxides, right? Because now you have the addition, the linkage of oxygen from there, right? Now this is tertiary oxide only. They are saying that when you heat the tertiary oxide, what you will have, very important thing, very simple, that you will have this nitrogen, right? This bond will break here, right? This bond will break here, right? This bond will break here. And here you will have the addition of hydrogen from the beta position. This is the beta position, right? This is the beta position, alpha beta. This is the beta position. Here you will have the hydrogen, right? This hydrogen will be replaced to this oxygen here, and you will have the linkage of NOH here, right? This is NOH, this is CH3, and one hydrogen, right? Sorry, CH3 and CH3. So here you will have nitrogen, CH3, and one OH, because one hydrogen is shifted here, right? Now, next thing that you will see is this pi bond is shifted here, and hence you will have, wait a minute, this pi bond is shifted. No, this is alpha, this is beta hydrogen, they are saying, right? So, okay, no, this hydrogen is not replaced here. Wait a minute. You will have this bond will break. Okay, this bond will break and the pi electrons will be shifted from this side, right? And hence you will have the formation of one alkene here. So basically in this step what you will have, you will have a tertiary amine oxide, right? From this oxide, this bond will break. You will have OH here and you will have double bond here. That is the thing that you will get, right? I'll give you one more example of this thing. For example, you have this thing. Now, firstly, so you need to understand whether it is tertiary or not. So if you talk about this nitrogen, it is linked to 3 carbon, it is definitely tertiary amine, right? It is definitely tertiary amine. What about beta hydrogen? This is alpha, this is beta, this is alpha, this is beta. But here it does not have any beta carbon, right? So that means either to this side or to this side, right? It can form alkene, right? Not to this side, right? So here, when you add oxygen, it will get converted to this thing, right? That means coordinate bond with oxygen, right? Once you have 3 degree amine oxide, this is tertiary amine oxide, at heating at a very high temperature, that is 160 degrees Celsius, what will happen? This bond will break. Where is this bond? This bond will break. This is NH2, yes. Any of the bond you can break. This bond will break. And this position, right? This is your CH3, this is CH2R. Here you will have the attachment of hydrogen and hence you will have nitrogen, CH3, CH2, R dash, and this is OH. You will have the formation of alcohol, and to this position, you will have the formation of double bond, right? And hence you will have the formation of alkene here, right? So this is the thing that will be formed here, right? Okay, this bond will break, double bond will attach here, H will attach here, right? So this is called Cope's elimination, right? This is called Cope's elimination. Okay, guys, this is called Cope's elimination. Okay, understood? Right? Everybody in the chat box? Everybody in the chat box, is that clear? Next is Hinsberg test, right? So this is to for the detection of 1 degree, 2 degree, 3 degree amines, right? You can distinguish 1 degree, 2 degree, 3 degree amines from here, right? So basically what we do here, we have this, right? So this is your Hinsberg reagent, right? We will react this with 1 degree amine. So basically what will happen, HCl will be eliminated, Cl from here and H from here, and you will have the formation of this N-ethyl benzene sulfonamide, right? Now, what is the catch here? That this product is having one hydrogen. That is why it is soluble in alkali. That is why when you will have a product which is soluble in alkali, you can say it is 1 degree amine. 1 degree amine. If you talk about, if you use 2 degree amines, in that case, definitely there will be elimination of HCl, right? This is a product. But in this product, you have no hydrogen on the nitrogen. That is why it is insoluble in alkali. It is insoluble in alkali. That is the reason we can say that when a product is found which is insoluble in alkali, we can say that this is your 2 degree amine. Third is tertiary. They have not shown here. Okay, let me draw tertiary also, because tertiary definitely will not react. Reason is you have N, this is R, this is also R, this is also R. Now I told you the first step is the elimination of hydrogen. There is no hydrogen over here. That is why in this case no reaction. If there is no reaction with the Hinsberg reagent, we can say definitely it is tertiary amine, right? It is definitely tertiary amines, right? Okay, understood? Now, Hinsberg reagent, that is benzene sulfonyl chloride. Hinsberg reagent react with primary and secondary, but it does not react with tertiary amines. With primary amines, it forms, wait a minute, where it is written, it forms a compound that is soluble in alkali. With tertiary, it forms a compound which is insoluble in alkali, right? Okay, that I have written here, right? Okay, they have written in a different language. Does not contain tertiary. Diethylbenzene does not contain any hydrogen atom attached to the nitrogen. It is not acidic, so it is insoluble in the alkali, right? Okay. Okay, guys. Now let us do the electrophilic substitution reactions. Everybody, is that clear what I have taught you till now? Is that clear or not? I am waiting for your replies, right? I'll see how many of you can reply here, right? That's a big question, no? Raghul, it's very easy to say here, ma'am, please complete. But how do I complete in a class which don't even respond, right? How can you expect me to complete, ma'am? Please do 10 lectures per week, ma'am. We will not respond in the class, ma'am. Right? We will take everything for granted, ma'am. Right? Yes, tell me, is that clear to you or not, everybody? Okay, Aditya is responding. Who else is responding? Keshav is responding. I have one question for all of you. Right? Do you want to study or not? Do you want to study or not, guys? If not, then let me know na why I am wasting my time here. I should give time to some other students, right? I should take class on NEET then, right? Where students at least respond to me, right? If you don't want to respond only, then why I am here, right? I should go and utilize my energy somewhere else, right? It's totally a waste of energy then. We want to, if you want to, then at least reply when I'm asking you if you're able to understand or not. At least this much you can write. Even I can't expect even this much from you. Then why even I am taking live session? I should put recordings only, na? Right? Isn't it? I should put recordings only if this is what you want. Even now I can't see any interest from you guys. Right? Leave it. Guys, how can you expect me to start? Firstly, tell me one thing. If I'm standing here and asking you, are you able to understand or not? You feel that, okay, I'll not speak anything, I'll not chat here. I'm not asking you to chit chat with me and hello, hi, good night, happy, how are you, this, that. I'm not asking you to chat with me, right? At least you can respond to what I'm saying. At least you can respond to yes if you're able to understand or not. If I can't even expect that from you, then what's the reason that I should be here? You'd give me one reason, right? You give me one reason for that. I am not going to teach. I am seriously very serious about it, right? If you can't respect a teacher, then how can you expect a teacher to teach you here? Right? I am not those kind of teacher who can just stand here without even students responding and they will be like, okay, I don't care if the students are able to understand. I do care. I do care. Right? So if I care, if you want me to care, then you should also care. Then you should also respect the teacher who is standing here from last 2 hours, not even taking one single break, right? And you are making such a mess out of this. Every day I have to do this, is it? Every day you want me to do this? Just imagine you are standing somewhere, you are asking, are you able to understand? Are you able to understand? And the students are sitting there. What if I just mute my mic and just stand here like this? Chalo. Now, if the next time I have to say this again, then and trust me, that will be my last lecture here. Right? Okay? That will be my last lecture. Uh, I am not asking you to say, hi, ma'am, how are you, ma'am? Have you had dinner, ma'am? Have you had this, ma'am? No, nothing I'm asking you like that. Right? Okay? So, this is my last warning to you. If after this also I have to ask this again and again, guys, where are you? Are you here? Are you here? Are you alive? Then guys, that is going to be my last lecture. Okay? Yes? Okay. Okay, very good, Aditya. Good to know that. Yes? Rahul, then obviously you can't respond if you're not here, right? I'm talking about those students who are sitting here from a long time and they are not responding, right? I'm talking about those students, not the students who have just joined. Now, let us see electrophilic substitution reaction, right? So, anilines have a very different concept of electrophilic substitution reaction. Why? You will have a very unexpected products here, right? So, let us see that. Firstly, you need to understand that whether it is meta-directing or para-directing, right? So this is the aniline. Now we know that aniline is going to give away the electrons, so it is plus M effect. Plus M means it is ortho-para-directing towards electrophilic substitution reaction, right? Now let us see that because of the negative charge at ortho and para position towards electrophilic substitution, it is ortho-para directing in nature, right? So now let us see if you add bromine water into it, right? If you add bromine water into it, what will happen? You will get a tri-substituted product at ortho and para position, right? Then what if you add, what if now second thing is, what if I want to have mono-substituted product? How, ma'am, how can I have mono-substituted product? That is by doing acetylation, that is acylation, right? So basically what you need to do, you need to convert this NH2 group to NHC double bond O CH3 group. That is called acetylation, adding the acetyl or the acyl group here. When you are adding the acetyl group here, that is COCH3, in that case, what will happen? Why you will get the mono-substituted product? Let us see. Firstly, mono-substituted product is obtained by this thing. That is this thing. Now, we will also give you the reason why this is so. Firstly, you will do the acetylation in presence of pyridine that we talked about, the acylation reaction, right? This one hydrogen is converted to COCH3. Then you will add bromine in the presence of acid. Here you will get the mono-substituted product. Ortho and para are the electrophilic positions here. Always para is the major product when there is no hydrogen bonding involved. So here para will be the major product. After this, you just need to do hydrolysis and you will convert back the CH3CO to hydrogen, right? Hence, you will have mono-substituted product. Mono-substituted product. You will get mono-substituted product from here, right? Now the reason is, ma'am, why it is so? Ma'am, why we are getting mono-substituted product? Let us see the reason behind that. Because if you talk about NC double bond O CH3, tell me one thing. Why this is ortho-para directing? Why it is ortho-para directing? Because of the lone pair availability on the nitrogen, right? Because of this lone pair availability on the nitrogen, it is giving the electrons to ortho and para position. Hence, the electron density on the ortho and very good. Aditya ma'am, Br2 and CS2 won't do that, ma'am. No, here it will not do that, right? Okay, here you need to add Br2 water, right? Okay, bromine water, right? So, because it is polar in nature, right? So, now this lone pair is going to shift here. Electrons are going to shift here on the ortho and para position in simple aniline. But when we talk about, when we have done the acetylation here, then what will happen? In that case, the lone pairs that were shifting on the ortho and para position, now they are busy. Where they are busy? They are busy in this thing. The lone pairs here are shifting in the resonance. The lone pair, for example, this is NC double bond O, this is CH3. We know that here you can have, this is lone pair single bond double bond. Lone pair single bond double bond is the criteria for your resonance. So we can say that resonance will occur. These lone pair will shift here. This pi bond will shift here. That is why you will have resonance here. Because of that, the availability of the lone pair on the nitrogen decreases. Hence, the electrophilic attack on the nitrogen will decrease, right? That is why its activating effect of NH3 group is less than that of amino group. It is less activating. It is giving less electrons at the ortho and para position. The lone pair of electron on nitrogen is less available. That is why you will have mono-substituted product here, right? Understood this thing? Why if you had directly amine, you add bromine, then you will have tri-substituted. But for mono-substituted, you need to do acetylation here, right? Okay, you need to do acetylation here. Next is very, very, very important, and this is the question that has been asked in JEE Advanced, right? Okay, this is a question that has been asked in JEE Advanced. I'll show you how they have asked this question, right? Okay. Okay. Thank you so much. Thank you so much for that. Now, this question is a question of your JEE Advanced. Right? Definitely you will see, ma'am, this is such a simple question. Why they have asked this thing in JEE Advanced? Yes, Abhishek, let me know in the chat box what is the doubt. Right? Now, this is aniline. You are adding nitrating mixture to it. Right? In your favor, what you were assuming that this is ortho-para directing. So, ma'am, we should get ortho and para product. I am saying you are getting meta product also. Then you are saying, ma'am, meta product may be 1 to 2%. I am saying, no, it's not 1 to 2%. It's 47% of meta product that you are getting. Like, ma'am, 47% meta product? I'm saying, yes, you are having 51% para. 40, the percentage is also important for you. Percentage is also, from percentage only the question has been asked. Okay, from percentage the question has been asked. I'll show you the question also today. 51% is para, 47% is meta, ortho is just 2%. I'm like, ma'am, why this happened? This happened because aniline is a base, right? Aniline, though it is a weak base, but it is still a base. And this H2SO4, this HNO3, it's a very strong acidic thing that you have added. This is also very good acid. This is also very, very, very good acid, right? So this is a base, you have an acid. So base, what is the quality of a base? Base always tries to take the proton. It tries to accept the proton. So it will accept the proton here, right? And this will become N positive H3. Acid tries to donate the proton. So acid will donate the proton to aniline and it will become anilinium ion. It will become anilinium ion. Now, this anilinium ion, right, it is not ortho-para directing. As you can see here, there is positive charge. So, pi electrons will jump here, right? That means it is showing minus M effect. It is meta-directing. It is meta-directing. Now, in that reaction mixture, the one, some of the aniline will be converted to anilinium ion. Some aniline will not be converted to anilinium ion. If you have direct aniline, like for example, you have 53% of aniline, right? Out of that 53% of aniline, you have 51% para and you have 2% ortho, right? Then 47% of it was anilinium ion that is converted into meta, right? 47% of anilinium ion is giving us meta product, right? That is how we are also getting meta product here, right? We want to remember the percentage. Yes, you need to remember the percentage also, right? 51% para, 47% meta, 2% is ortho, right? Okay. Yes, everybody, that is the percentage. Now, in this strongly acidic, aniline is protonated to anilinium ions, which is meta-directing that I have shown you here, right? Now, let us see. If you're like, ma'am, I want to get mono-substituted para product, what I should do? I'm telling that, students, you should again do the acetylation. This is again a very important question, right? So, doing the acetylation, one hydrogen will be substituted by COCH3. Done. COCH3, it is substituted here. Easy. After that, you are adding the nitrating mixture here, right? Okay, after that you are adding the nitrating mixture. It will give you para substituted product, right? What we observed that after the acetylation, see, after acetylation, what will happen? This nitrogen, it will not be able to form the anilinium ion, right? Because you have changed the NH2, right, to acetylation. That is why it will not be able to form anilinium ion. That is the reason you will get maximum para product, and hence when you do the nitration here, you will attach N2 group here, right? Then again, after adding water here, you will convert this acetylation to back to the hydrogen. So it will be NH2 here, right? That is how you will get mono substituted para product, right? Okay, understood. Bromine and nitration are two very important cases here, right? Everybody tell me, are you able to understand this or not? Are you able to understand this or not? Everybody in the chat box, right? Bromine and acetylation. In bromine, you are getting tri-substituted product. If you want to have para-mono-substituted bromine, then you need to do acetylation. In nitration, you are getting meta product also due to anilinium ion, which is meta-directing. If you want to have mono-substituted para product, you need to do the acetylation. Okay, is that clear or not? Is that clear or not? Okay, no worries, Raghul. Yes, everybody. Now let us see what is sulfonation. So this is aniline, this is H2SO4, right? So here, this is acting as a base, this is an acid, right? Again, what will happen here? Again, what will happen? This will accept one proton and it will donate one proton. So it will become NH3 positive, HSO4 negative, right? Now, anilinium hydrogen sulfate is formed. This is also asked in JEE. This is also asked in JEE. Okay, so don't ignore the reactions just like that. They are your 2024 questions only, right? So after this, you are heating it at 453 to 473 Kelvin. Now, this whole thing is internally transferred to the para position. So you will have SO3H here and NH2 here, right? Now, students, very important thing. This is a base, just like amino acids, no? This is an acidic group. It will donate the H positive here. It will become NH3 positive. It will become SO3 negative. And when you have in a single compound, you have acid and basic group. And when there is internal transfer of hydrogen, that is called Zwitter ion. So on sulfonation, it will form Zwitter ion, right? Okay. On sulfonation, it will form Zwitter ion. Yes. Okay. Okay, guys. It's a very, very important question again asked in your JEE, right? Okay. Next is Friedel-Crafts reactions. Now, Friedel-Crafts reactions are not shown by anilines, right? Reason is, we know that this is a base, right? And this is, you are adding alkyl halide here. But we know that this is a Lewis acid. We know that whenever you have base, it was the acid was attacking on the basic part. So this AlCl3 will attack on this lone pair and you will get NH3, NH2 positive, AlCl3. Right? This is what you will get, right? You will get this salt here because this will have no role here. Why? Because this is a base, this is an acid. They will react with each other to form the salt here, right? So, aniline does not undergo Friedel-Crafts reaction, whether it's alkylation or acylation. The Lewis acid, that is why to add the acyl group, what we did, to add the acyl group on this hydrogen, what we did, we added maybe acyl chloride, hydride, right, anhydride in presence of acetic acid, right? Now, you have nitrogen of aniline acquires positive charge and it acts as strong deactivating group. Okay, understood, right? Now, what is diazonium salt? As I have told you, from aniline you prepare diazonium salt, right? How it is prepared? You have aniline, you add NaNO2 in presence of HCl, or directly it is written HNO2, or directly it is written HNO2. Then at 0 to 5 degrees Celsius, that means at a very cold temperature, this diazonium salt is stable, right? This will be replaced by N2Cl. So basically what is this? This is benzene, above it is NH2. It is converted to benzene, and here you have N2Cl, positive and negative. And this diazonium salt has so many reactions, right? Okay, it has so many reactions that we are going to see, right? Okay, physical properties, benzene diazonium chloride is colorless crystalline solid. It is readily soluble in water and is stable at cold temperature at around 0 to 5 degrees Celsius, but reacts with water when warm. When you react it with water when it is warm, it will give you phenol plus N2 gas, right, plus HCl, right? It will give you phenol here, but only with water it will react when it is warm, right? So it readily soluble in water, reacts with water when it is warmed, right? Third is it decomposes easily in dry state, right? It will decompose, it will be dissociated in the dry state. Okay. Yes, HNO2 is prepared in situ, right? With NaNO2 and HCl. So these are the very, very important reaction of diazonium salt. Very, very important, as you can see here. Right, first is Sand-Meyer's reaction, where you add a salt of copper, right, with HCl to convert it into chloro or bromobenzene. Right, this we have done in haloalkanes as well. Right, then if you add CuCN in presence of KCN, then you can replace this N2Cl with the Cn. Right, you will have the formation of cyanide here. Right, now what is Getterman reaction? If you have copper salt is not there, but you have copper powder, in presence of HCl it will become chlorobenzene, in presence of HBr it will become bromobenzene. These are all the reactions that we have done in haloalkanes and haloarenes as well, right? Okay, right, very good, very happy to know, Nikesh. Yes, very happy to know. Now next is reaction of other reaction. Now these reactions are also very important. Diazonium salt with Ki, you will substitute N2Cl with iodine, right? If you want to have fluorine here, then you will add HBF4 and heat it. Very important. You will add HBF4 and heat it, you will get fluorine here. But very important thing, I think that is on the next page, that is similar reaction. If to this N2Cl, you are adding HBF4, but you are not heating it, you are adding NaNO2 and Cu couple and heating it, then you will get nitrobenzene. But if you are heating it, then you will get fluorobenzene, right? Then you will get fluoro. This is a two reactions that are very similar to each other. When you have HBF4 fluoroboric acid, when you are adding NaNO2 and copper couple and heat it, then you will get nitro. But when you add HBF4 and you directly heat it, then you will get fluorobenzene, right? Okay, these little things are very important, right? Okay, yes, Ball-Schiemann, very good. This reaction is called Ball-Schiemann reaction. Very good. This reaction is called Ball-Schiemann reaction. Not this one. This one has a name Ball-Schiemann reaction. Okay, very good, Aditya. Very good. Now, you have this is called Ball-Schiemann reaction. Now, very important thing, if you are adding H3PO2, a very strong acid you are adding, then this N2Cl will be replaced by hydrogen, and this is also asked to you in JEE so many times, right? This is also a very simple reaction. Usually students ignore this reaction, but they ask you this reaction, right? Then you have, if you add CH3CH2OH, very important, this has also been asked, right? Okay, then you have benzene here. Now, when you add H2O and you warm it, then you will have phenol here, right? Okay, guys, everybody. Now let us do azodize, right? The coupling reaction of diazonium salts, right? So azo products obtained have, azo means N2, right? Which will have N2. Extended conjugate system having both aromatic joined through this bond. Azo bond is formed there, right? These compounds are often colored and are used as dyes. So now let us see what are the different dyes that you will have. So first is with the phenol, right? With the phenol, what will happen to the para position? It will try from the para position. Then it will, if there is no para position is not available, then it will use the ortho position, right? So this phenol, the para position is this one. This is your Cl. HCl will be eliminated and they will join together. This will be benzene N2. Then you will have again this benzene. Then you will have OH. And this is an orange dye that is formed. How you can remember? With the phenol. It is ol, orange. O for phenol. And this is orange. Ol, orange. Right? With phenol, you will have orange dye. But with aniline, you will have yellow dye. So basically, again, the same thing will happen. HCl will be eliminated. They will join together to form a couple. And here you will have the formation of yellow dye. Okay? Here you will have the formation of yellow dye. Okay. There are also beta naphthol, how it is used, that we will do in the question itself. Right? Okay, that we will do in the question. Everybody, last reaction. After that, we are going to start the questions, right? Which are actually more important than the theory. Because theory though is same, right? Theory is also same for NEET, for JEE, theory is same. But the way they ask the question is different, right? It's not like in JEE, they have a different syllabus only. Some of the reactions are added in JEE, but the way they will ask you questions is very different, right? Okay, so now let us see that. Primary amines react with carbon disulfide. So now we are going to use, this is a distinguished test, right? It will distinguish 1 degree, 2 degree and 3 degree, right? This is Hofmann's mustard oil test. So basically here, firstly, we will use carbon disulfide with the primary amines, right? Whether it's aromatic or aliphatic, they will react with carbon disulfide, right? What will be formed? To this double bond, you will have SH. Here to this sulfur, you will have one hydrogen. And to another bond, you will have NHR. This NHR will be attached here, right? Okay. So alkyl substituted is formed here, right? After this, you are adding mercuric chloride here, right? So when you are adding mercuric chloride here, 2-3 things can happen. If it is a primary amine, then adding the mercuric chloride, it will form mustard, it will give you mustard oil smell. That is RNC double bond S. This is giving you mustard oil smell. This will be formed and a black PPT will be formed of HGS. A black precipitates will be formed here. You can say that definitely it's a primary amine, right? Whether it's aromatic or aliphatic, right? Okay. If you have 2 degree, then definitely it will give the reaction again here. This one S is converted to H here. Other is converted to NR2, right? So this thing will be formed here, right? This thing will be formed here. Now, when you add mercuric chloride, in this case, there is no reaction. When there is no reaction on adding mercuric chloride, this is a 2 degree aliphatic or aromatic amine. That is confirmed. In the third reaction, wait a minute, third is that tertiary amines will not react with carbon disulfide, right? They will not react. They will not even give this step, right? Okay, that is called mustard oil test, right? Everybody, can you please explain again? Okay. So guys, what you need to do here, this is your carbon disulfide, right? Okay, I'll just show you here. This is your carbon disulfide. This is how it looks like, right? If you have primary, what will happen? This is SH, NR, because primary is what? Primary is NRH2. One hydrogen is shifted here. You are left with R and H. This will be formed. When it is reacted with HgCl2, it will give you a mustard oil smell, and along with that black precipitates of HGS, right? But if you say that you have 2 degree, 2 degree means you have R2NH. Hydrogen will be shifted here and you are left with NR2. Then you add mercury chloride, there is no reaction after this. But if you talk about that you have R3N and you have disulfide, there is no reaction because here you don't have any hydrogen which can attack on the sulfur, right? Okay, understood, Pala, right? Okay, is that clear or not? Everybody, is that clear or not? Ma'am, why nitrogen acting deactivating group? Where nitrogen is acting as deactivating? In aniline you are saying? In aniline you are saying? Where nitrogen? In aniline, nitrogen is not acting as a deactivating group, right? Here nitrogen is acting. In aniline it is acting as a deactivating group because pi electrons are shifted to the nitrogen side. So whenever it is showing minus M effect, it is taking out the electrons from, because here nitrogen does not have lone pairs, right? It is electron deficient. So it will take out the electrons from the benzene. Whenever there is minus M, that is deactivating. Okay? Okay? So now let us start with the questions. Oops. Okay. So guys, I want all of you to be active here, right? Because we are going to apply all the things that we have studied till now. Everybody, now I want your answers because after such a hard work, I have picked out some questions from you, for you guys. Now I want all of you to answer this. Okay? Yes. Avinash is saying, ma'am, why aniline does not react with Friedel-Crafts reaction? Because aniline is a base, and in Friedel-Crafts you use Lewis acid, that is AlCl3. So acid will attack on the aniline. Alkyl chloride or acyl chloride will have no meaning, right? That is why it is not showing that. Okay? Yes, everybody? Nitrobenzene only. Yes, nitrobenzene is deactivating only. Right? Okay. Now let us start the questions. Everybody, are you ready? Everybody. And those students who are skipping theory, still you can skip. If you know theory, like you are very confident in theory, you can skip theory. But questions you should never skip. Right? Okay. Yes. Everybody in the chat box, shall we start or shall I give you break? Tell me one thing. Shall I give you break and then start the question, or you want to complete the question now only? Right? Everybody in the chat box. Yes. Yes, these are your previous year questions only. All of the questions are previous year only. Right? In fact, last 2-3 years only. Right? Okay? Yes. But I want all of you to answer, right? Only then there will be no break. Otherwise, so I'll give all the questions as homework only. If you want me to teach you the questions as well, then I need response from you. Because I have completed the chapter. My responsibility is done. Now I am doing the extra work here, right? So for that, I want all of you to give response in the chat box, right? Okay. So the first question is, they are saying which of the following reaction is incorrect? Sorry, which of the following reaction is correct? Now, first reaction they are saying, you have HNO2 and here you are adding water, right? And this is a very simple reaction because this CH3, CH2, it will be converted to CH2. This will be converted to N2Cl positive negative. After that, adding water, it will be replaced by OH, right? So this will be the answer that you will get. But here their answer is ethanol, but our answer is propanol. So this is a wrong answer. So this is not a correct reaction, right? This is not a correct reaction. If you talk about this thing here, right, HI is added here, right? Because HI, this is positive, this is negative. So negative part will attack on the less number. Wait a minute. This is the negative part, right? Negative part will attack on less number of hydrogens. It has only one hydrogen, it has two hydrogens. That means this bond will break. Iodine will be attacked here, hydrogen will attack here. So hence, you will have the formation of this bond. That is the correct answer. This is the correct reaction. No, second is the correct. Why? Because this is positive. Whenever you have double bond, right, and you want to break this double bond, negative will attack on the less number of hydrogen according to Markovnikov rule. So the same thing is happening here. Negative is attacking on the less number of hydrogen, and hence you will have the formation of this is the product that will be formed here, right? Next is when you are adding Br2 in UV light. Now, whenever you have UV light, Br2 is added in presence of UV light. In that, Friedel-Crafts reaction will happen. Sorry, Friedel-Crafts I am saying, free radical reaction will happen, right? And allylic hydrogen will be substituted. There will be substitution reaction. So this is double bond. This is the allylic hydrogen. This hydrogen will be replaced. Wait a minute. This product, the product will be double bond will stay as it is, and this hydrogen will be replaced by this bromine. So the answer, this is the correct product. This is the wrong product, right? Okay, this is the wrong product. Let us see the fourth one. In the fourth, you have C2H5. Okay, tell me what is the answer for Hofmann bromide reaction? What is the answer for Hofmann bromide reaction? Tell me that thing, right? What is the answer for Hofmann bromide reaction? Tell me, is fourth the correct or the wrong answer? For Hofmann, this is Hofmann bromide, right? This CO will be eliminated, hence the answer will be C2H5 and this is NH2. If you want to have this product, then you need to use lithium aluminium hydride. If you are using Hofmann bromide, this carbonyl will be eliminated here. Very good. So answer will be this one. So the correct answer is second is the correct answer, right? Second is the correct answer. Next question, everybody in the chat box, try this question yourself. Everybody try to answer this yourself. CO hole removed. Yes, very good. CO hole will be removed. They are saying the product A is formed in the following reaction. Okay. You have the whole product is, you have aniline, NaNO2 HCl, 0 degree. Then you use Cl2. Very easy, simple question. JEE mains question, right? This is JEE mains. This is JEE mains. Ma'am, the reason why you are taking GOC. Why I am not taking or I am taking GOC? Yes. So here NaNO2 plus HCl, this will form Diazonium salt. After that you are using, I'll give you the hint, you are doing the Sand-Meyers reaction. This is a hint. Sand-Meyers reaction. This is a hint. I have already given you the hint. Right? Okay. One student is saying C. Very good, Saransh. Very good. Very good. Very good. So what will happen here? Because of this, what will be formed? You will have the formation of this NH2 will be replaced by N2Cl. N2Cl, that is benzene diazonium chloride. After that, when you add Cu2Cl2 and HCl, what will happen? You will have the formation, this will be replaced by Cl. That is chlorobenzene will be formed. That is Sand-Meyers reaction will occur at this place. Right, so C is the correct answer. Next question, everybody in the chat box. following is a confirmatory test for the aromatic primary amines. Identify reagent A and B. Yes. This is, I don't expect you to answer this. Why? Because I told you that we will do this in the questions, right? If you have revised it, so basically I'll give you a hint, that is beta naphthol. Here diazodie is formed and beta naphthol is used here. Okay, azodie is formed and beta naphthol. Beta naphthol, guys. I know the confusion will be between 3 and 4 only. I know that. So let us see what is going to happen here. Let us see what is going to happen here. So guys, when you have NH2 and you have A, you are making N2Cl. That means here you are using NaNO2 HCl at 0 to 5 degrees Celsius. That is the reagent to make diazonium salt. Right? Once you have formed diazonium salt, then you are using B, then you have scarlet red dye. Now with phenol you had orange dye, right? With aniline you have yellow dye. What is this scarlet red dye? That is formed by this compound, right? How it is formed, everybody? How it is formed? Let us see. This is your diazonium chloride, right? And this is the product. This is a reactant. Okay. Right. Now, on one benzene, one, after leaving one, you have OH. Yes. Okay. Now, what will happen to this position? To this position, this para, this thing will add N2, right? And then you will have the formation of this scarlet red dye, right? This is the formation of this scarlet red dye. This is actually your scarlet red dye. Everybody, this is your scarlet red dye. Is that clear to everybody here? This is your scarlet red dye that is formed. So, fourth will become the correct answer. So, fourth will become the correct answer because here it is NaNO2 HCl 0 to 5 and here this is the B that they are using to form the scarlet red dye. Okay? Right? Okay. Coupling reaction. Right? Next is the products formed in the following reaction, right? The products that are formed in the following reaction scheme are respectively. Now, this is a very good question, right? So, here, what are the products formed in the following reaction sequence are? Firstly, they are doing diazotization, is it? Concentrated HNO3, concentrated H2SO4, right? Yes, they are making, from benzene they are doing this, concentrated HNO3, concentrated H2SO4, right? This is a nitrating mixture, right? This is a nitrating, I am giving you the hints here. This is a nitrating mixture, right? This SnHCl will cause the reduction will occur. You will have the formation of A. A is something, after that you will do the diazotization, right? Diazotization. I am giving you all the hints, guys. Then you are adding phenol. Then I am giving you the hint, coupling reaction will occur and orange dye will be formed. Orange dye is formed, right? Orange dye is formed here. Right? Anybody, all the hints I have given you here, right? So, all the reactions you have done, right? It's just that they will not ask you the direct, they will ask you A, B, C, all the questions will be like this only, right? Okay? And these are 2024 questions, right? Okay? Let us see that. First is A is aniline. Very good. Very good. A is aniline. Okay. What about B? Let me see your answers in the chat box. Let me see your answers in the chat box. Everybody. Hacker is saying 2 is the second is the correct answer. Okay. Be careful. I am saying that azo dye is formed in the end. Azo dye. In second, there is no formation of azo dye. Where azo dye is formed? Here also no azo dye is formed. Azo dye is formed here and here. Right? Now, Aditya is saying 3 is the correct answer. Very good. Now, let us see what is going to happen here. Firstly, because of this HNO3, you will have the formation of nitrating mixture. You will have the formation of NO2 group on benzene. Then after the reduction with tin HCl, this NO2 will be reduced to NH2, right? So this is the formation of aniline. That means this aniline is shown in 3 forms, right? Three options. Now, to this aniline, you are doing diazotization. That means it is converted to N2Cl. When you have diazonium salt, right, with the phenol, this is diazonium salt, N2Cl, with the phenol. Now, from the para position, right, here HCl will be eliminated and hence you will have the answer. That is, this is N double bond N, this is benzene, and this thing will be formed. This is orange dye is formed here, right? Orange dye is formed here, right? So answer, as you can see, definitely not this. This thing is formed, so third will be the correct answer. From the para position, hydrogen is replaced. So 3 is the correct answer. Okay? 3 will become the correct answer. Right? Okay. Okay, guys. Next question is, given below are 2 statements, right? This I have told you, today only we did, like today all the questions we did today only, right? So I especially mentioned that, okay, it will, Lissagne's test, though I know that is in practical chemistry, I'll teach you that, right? But still I'll give you one hint here. Aniline reacts with concentrated H2SO4. Can you tell me what was formed when aniline reacts with concentrated H2SO4? When aniline reacted with H2SO4, right, this is a base, it reacts with an acid, it formed NH2 and SO3H. This thing was formed, okay? Followed by heating at this gives ammonium benzene sulfonic, which give blood red color in Lissagne's test. Now, I know that we have not done this, so I'll just show you here only that this statement is true, right? So this is aniline. When it is reacted with concentrated H2SO4, it will give you, this is aniline, right? It will give you NH3 positive, SO3H, this is negative. After heating, it will give us NH2, right? And this is SO3H. Now, this on Lissagne's test, this will give us this will give us blood red color, right? And that blood red color is of SCN2 positive, 3 positive, right? Okay, so this is a blood red color that you will get. Blood red color. That is the true statement. This is Lissagne's test. Right? Okay. So that is the true statement. Right? That is why I have told you myself only. Right? Now, next is in Friedel-Crafts alkylation. Right? Don't worry. We will do that in the practical chemistry. Right? So, in Friedel-Crafts alkylation and acylation reaction, aniline forms salt with AlCl3. Is this true? Yes, that is why we were saying that it does not give Friedel-Crafts alkylation or acylation reaction. Why? Because aniline that will form salt with this NH2, right? It will become this AlCl3, right? This will be the answer that you will get, right? That is why this is also the true statement. So both the statement are true. Both are true, right? So fourth will become the correct answer, that both the statements are true. Yes, it's a sulfonic group. Yes. So if both the statements are true, that is fourth is the correct answer, right? Okay. Next question. Now you will feel that this is a difficult question, but actually it's a very simple question. You might feel that this is a difficult question, right? Once I told you that how to solve this, you'll be like, ma'am, this is such a simple question, right? So X gram of ethylamine. Ethylamine is C2H5NH2 that is subjected to react with NaNO2, right, with HCl, right, followed by water. When it reacts with this one, it will form Diazonium salt, C6H5N2Cl. This is positive, this is negative. On reaction with water, this N2Cl will be converted to C2H5OH plus N2 will be released here, right? Okay. Now, they are saying that by water evolved dinitrogen gas which occupied 2.24 liter. So here 2.24 liter of this is formed. 2.24 liter of volume of that is formed. Right? They are asking you X is. That means they are asking you the amount of ethylamine. Guys, we have to apply mole concept here. Right? It's just that they have mixed two things. In organic chemistry, they have mixed mole concept. That is why students will be like, ma'am, that question was really, really tough, ma'am. Very tough question. Such a simple question, yeah. Right? So here what you will do, can you calculate? This is 1 mole, this is also 1 mole. Right? So that means by using stoichiometry, we can apply the answer, right? So here number of moles of N2. First you need to know the number of moles of N2. That is given volume 2.24 divided by molar volume, that is 22.4. So here the answer will be 0.1 mole. Is it? The answer will be 0.1 mole. Okay. Answer will be 0.1 mole. You cancel this out. The answer will be 0.1 mole. Right? So if you have number of moles of N2 is 0.1, then according to stoichiometry, the number of moles of ethylamine will be same. Ethylamine will also be 0.1. Right? They are asking you the mass here. So number of moles is also equals to given mass by molar mass. What is the molar mass of ethylamine? Everybody in the chat box. What is the molar mass of ethylamine? That is 12 into 2 plus 5, right, plus 14 plus, this is 7, right, plus 7 plus 14, right. So it will become 24 plus 21, so it will become 45, right. So answer is 45. Given mass by molar mass into 0.1, so X will become equals to 4.5 gram, right? Or if they are asking you, see, a very, very silly mistake that students can do, right? They can say that, ma'am, here I have written the answer as 45 only, right? But guys, they have also mentioned into 10 raised to power minus 1. So if you want to convert it like that, it will be 45 into 10 raised to power minus 1 gram. So here answer will be 45 into 10 raised to power minus 1, right? Okay. So answer is 45 is the correct answer. So basically these kind of questions are like they have asked you in 2024, where they have combined a very simple stoichiometry along with the reaction. So only if you know the reaction and you know the mole concept also, then you will be able to answer this. So I feel that these kind of questions are really good and they can be asked, and I won't consider it as a difficult question. It's a very simple question, right? Okay, the reaction is very simple. The concept is very simple here, right? Okay. Yes, guys. Next is, let's talk about this reaction. Now, this is a very, very important. I will say that this is a good question, right? This is a good question, right? You can get confused here. So, this is a good question. Okay, everybody? Everybody in the chat box, try to answer it. Everybody in the chat box, try to answer it yourself. Try to answer it. Because here you need to know the mechanism, right? Try to answer it yourself. Try to answer it yourself. Everybody. You have two bromines. I'll give you one hint here. The lone pairs are going to attack here and the pi bond is going to shift. And then the bromine is going to leave from this side. Right? Okay. Ma'am, worth teaching. Thank you for your hard work. Welcome, Rathi. Welcome, welcome. No idea? Okay. So this is a very good question. Okay. So let us see how to answer this. Okay. Yes. So let us see the mechanism here. It's a different question, right? I won't say this is a very direct question. This is not a direct question, right? So you can easily get confused here, right? So now let us see. This is your double bond. This is Br and this is Br, right? You have the addition of NMe. What is the addition of NMe twice? These are the lone pairs, right? Is it? Is it? Yes. Me twice and this is hydrogen. Now what can happen here? What will happen here? These lone pairs will attack. These lone pairs can attack here, right? Wait a minute. They will attack on this carbon, right? Yes. They will attack on this carbon, right? So the lone pairs will attack on this carbon, right? So transition will happen. The lone pair will attack on this carbon, right? Because this carbon cannot handle 5 bonds. So the pi electrons will jump here. This Br negative will leave from this side. This is minus Br negative, right? So very important reaction it is, right? So here you will have double bond here. This is Br, right? And this is Me and this is Me. Because hydrogen will also be replaced. Now tell me, is first step clear to you or not? Is first step clear to you or not? Everybody in the chat box. Is first step clear to you or not? Everybody. Everybody, is first step clear? Yes? Third you are saying? Okay. Okay, we'll see what is the correct answer. We'll see. Just give me a minute. Now you have lone pairs here, right? Lone pairs here. Now students will feel that, ma'am, where the hydrogen will leave. So basically what will happen, the hydrogen will stay here, only it will be positive. After that hydrogen will leave and the bond will shift here, right? If you want to go through the full mechanism, then it is like this. Then after this I can draw that double bond is here, this is Br. The next step is very important. This is N, this is methyl, this is methyl. Now here you have the lone pairs, right? Now what will happen? These lone pairs are going to attack on this one. Why? Because here Br negative will be taken out, right? And hence you will have a transition state, not a transition state, but a nitrogen which is linked in to 2 carbons here, right? So this nitrogen now is linked to 1 carbon here, as in linked to 1 carbon here. It is having 2 methyl groups, right? And it is having this positive here, right? Okay. So this cyclic structure is formed. Okay. So this cyclic structure is formed. Are you able to understand this or not? Are you able to understand this or not, everybody? Are you able to understand this or not? A cyclic structure is formed here, right? Okay. Please do electrochemistry. Don't worry, I'll do electrochemistry. Firstly, tell me that are you able to understand till here, right? So firstly, lone pairs will attack on this carbon, right? Pi bonds will shift here, Br negative will leave, right? Now this nitrogen is having 4 bonds. Hydrogen will leave from this side, electrons will jump here. Now after that, there will be internal shifting, right? So internal shifting means internal attack. this lone pair will attack on this because this is partially positive, partially negative. So the lone pairs will attack here. Br negative will leave from this side, right? And hence you will have the formation of this cyclic product, right? Okay, yes, okay. Now, after this, again, what will happen? Because see what they have given you two equivalent. What if they have given you only one equivalent? Then the answer will be this. If they have given you only one equivalent, then the answer will be this. They are saying that two equivalent. That means two, second also is adding here. So it is N, this is N, right? This is N, Me2, and this is the hydrogen here. Now what will happen? This lone pair is going to attack on this carbon, right? And this electron, these electrons are going to shift on this nitrogen, right? So what will happen? What will be the final product here? What will be the final product here? That this is your pi bond, right? The nitrogen is attacking on that carbon. So here you will have nitrogen. Here you will have two Me groups, right? Two Me groups, right? One hydrogen will also be there, but hydrogen will leave and donate the electrons here. So it will become Me only, right? The same thing that has happened here will happen here. Now, this old Me group, right? It will take electrons from here and become neutral, and hence it will become Me, and this is also Me. So basically what will happen to this double bond? To this double bond, leave one carbon, you will have NMe, Me twice, right? So here let us see what is the correct answer. Leave double bond, right? This is the correct answer. Third is the correct answer, right? To this double bond, leave one carbon, you will Me twice, and to the adjacent also you will have Me twice. That means third will become the correct answer. Okay? 3 is the correct answer, right? Okay. Okay, yaar. Okay, thank you. I'll blush now. Now, tell me guys, is that clear to you or not? Is that clear to you or not? Right, I'll start blushing now. Yeah, I know what kind of love, right? Yes. Now that I can see through the chat only, right? What a student is telling, right? And what they mean by that. Ma'am, please once again explain. Okay, so let us see this mechanism. What is happening here? This lone pair is attacking on the pi electrons. Any carbon it can attack here because pi electrons are very loosely bound to each other. They are not very strong, right? They have sideways overlapping. So lone pairs will attack on any of this carbon. I am just assuming it attacks on this carbon. Then what will happen? Pi electrons will shift here and they will form a pi bond here. Then this carbon will eliminate this Br because carbon can only handle 4 bonds, right? So Br will be eliminated. Now to this nitrogen you have 4 bonds, right? This hydrogen to Me. That is why it is having a positive charge. Then again H proton will be eliminated and the bond will shift here and make the nitrogen stable, neutral. Right, now you have NMe. Now this is a very important step that here internal shifting of lone pair will occur. That means lone pairs, they are looking for something which is electron deficient. We know that carbon and Br is electropositive, carbon is electronegative. That is the reason these lone pairs are going to attack on this carbon because that is electropositive, electron deficient. It will attack here, it will form a cyclic structure like this. Now the second equivalent lone pair will attack on this carbon, right? It will attack on this carbon. These electrons will shift here. It will become NMe, right? And when this will attack here, it will become NMe. So this will become the final product. Okay? Okay. Yes. Everybody. Okay. Now, is that clear? This was an important question, guys. Okay. Now, next one is Phthalamide is made to undergo following sequence of reactions. Now phthalamide, what is phthalamide, guys? What is phthalamide? Anybody in the chat box? What is phthalamide? This is basically phthalamide. They are saying firstly it reacts. This is Gabriel phthalamide only, right? I have given you the structure of phthalamide. Now next is your duty. Okay, I have given you the structure of phthalamide. Now next is your duty. What will happen here? You have KOH. You have KOH. I'm drawing it here only, right? So it's like this. This is your phthalamide, C double bond O. This is C double bond O. This is N and this is H, right? Now, when you're adding KOH here, this H will be replaced by K, right? This H will be replaced by K. After that, you are adding benzyl chloride. What is benzyl chloride? It's like this. This is benzyl chloride. This is like Gabriel phthalamide reaction only. CH2Cl. So when this is your whole R part, this is your R part, this is X. So when you add benzyl halide, alkyl halide here, what will happen? Right, this K will be replaced by R part. R part is this one. So it will be CH2 and this is your benzene. Is it? CH2 and this is your benzene. So this thing will be formed in the end. Right? This is same as, this is not same, this is Gabriel phthalamide only. It's just that they have replaced R with this benzene CH2. Right? Okay. Yes. Now tell me how many how many pi bonds are present here? Right? 1, 2, 3, 4. How many pi bonds present in product? Total number of pi bonds they're asking. No? 1, 2, 3, 4, 5, 6, 7, 8. 8 pi bonds are present. Right? 8 pi bonds are present here. Is that clear, guys? Is that clear, guys? It is 8 is the correct answer. Okay? 8 is the correct answer. Next question is same as that we did before. X gram of ethanamone, okay, ethanamone was subjected to reaction with ethanamone. Wait a minute. With NaNO2HCl followed by hydrolysis, liberate this. I doubt this is ethanamone. It is generated completely with this. Wait a minute. Is it ethanamone? It is not ethanamone, it is ethanamine. Okay. Okay, it is ethanamine. Right. So I was like, now ethanamine, that means it is the same reaction C2H5 NH2, right? That is subjected to this NaNO2, you can say HNO2, right? It will form C6H5OH, not OH, you can say N2Cl positive negative. After hydrolysis, it will form, this is the same question, okay? This is OH, this is N2. Now they are saying that HCl is generated, the HCl generated was completely neutralized by this much of NaOX, right? So HCl will be generated here. They are saying this is completely neutralized by NaOH. That means if this is, it's just the way of asking question is different, right? The last line is different. This is where students will get confused. If this is 0.2 mole, then this also should be 0.2 because the same amount should neutralize each other. If this is 0.2, this is also should be 0.2. If this is 0.2, that means this also should be 0.2 only, right? This also should be 0.2 only. So now they are asking you the gram of ethanamine. So this is number of moles of ethanamine, that is this one, right, is equals to given mass by molar mass. Molar mass is 45. Now number of moles is 0.2. So X is equals to 0.2 into 45. That becomes 9 gram. Right. So answer is 9 gram. Right. So answer will become 9 gram is the correct answer. Okay. 9 gram will become the correct answer. Okay. Yes, everybody. Ethanamine. Yes. Okay. Okay, everybody. Okay, guys. Is that clear to everyone? So answer becomes 9 grams. Next question is similar to this only. 9.3 gram of pure aniline. They are saying that you have pure aniline. Okay, try to answer it yourself. You have aniline. Upon diazotization, followed by coupling. Upon diazotization, it will form N2Cl. Followed by coupling with phenol. With the phenol, it is going to make this kind of product, isn't it? This kind of product will be formed. That is orange dye. Right? The mass of orange dye produced is dash. This is what they are asking you. Right? The mass of orange dye produced, they are asking you. Right? Okay, everybody. Try to answer it. Try to answer it. Everybody in the chat box. Everybody in the chat box, try to answer it. So here you need to know the formula, right? So basically what you need to understand is they have given this 9.3 gram, right? And here what is the molar mass, right? So it is basically C6H5NH2. What is the molar mass of this one? 6 into 12. 6 into 12 plus 5, 6, 7 plus 14. That will turn out to be 93 gram per mole. Right? Now, what about this one? Here the mass is x gram, but the molar mass is C6H5N2C 1, 2, 3, 4, 5, 6. C6. H is 5, no. H is 4. H4OH. Right? This will be the question. This will be, try to solve this. Just add the values here. Just add all the values. 6 into, right? Basically, it's a basic calculation only, right? So, this is how many carbon you have. 12 into 12. Right? 12 into 12. Wait a minute, 6, 6, 12. 6, this is also 6, okay. Yes. This is N2, nitrogen is 14 into 2, plus hydrogen is 5, plus oxygen is 16. Now everybody, what will be the molar mass here? Right? Okay, let me calculate it. It will be, wait a minute, try to calculate it. It will be 12 into 12, 144 plus 28 plus 5 plus 16. It will be, wait a minute, some mistake have we done? Okay, hydrogen we have not added 5 hydrogen. More 5 hydrogen should be added. This is 4, 5, 10 hydrogens we have, right? 10 hydrogens we have. Wait a minute, now let me do that again. So it will be 28 plus 26. Wait a minute, some mistake are we doing? It should be 199. 5, nitrogen 14, 14 into 2, 6, this is that only. H4, oxygen is 16. Hydrogen is 1, 2, 3, 4. 4 OH. 1 hydrogen is here. Or maybe some calculation mistake. Right? It will be 199. Okay. It will be 199 gram per mole. And this is 93 gram per mole. Now you just need to make it equal because they two will be equal to each other. right? Number of moles. We know that number of moles of this and this should be equal, right? So here the answer will be, it will be 9.3 by 93 equals to x by 199 equals to, this will become 0.1, this is x by 199, so it is 19.9 gram of this is formed, right? 19.9. Orange dye is formed, no? So NH2, how come it is missing? Okay. So answer is 19.9. Right? Okay, guys. Okay, can you please explain again? Students, see, it's a very simple thing. You will have aniline on diazotization, that means HNO2 at 0 to 5 degrees Celsius. You will have diazonium. Then on adding phenol, right, on adding phenol, you will have orange dye, that is this kind of thing will be formed, right? So we know that number of moles of orange dye formed is equals to number of moles of anilines. So we will calculate the number of moles of, here we have aniline, here we have aniline, and this is the orange dye, and this is the orange dye, right? This is the orange dye. So number of moles will be same. Here mass will, molar mass you can calculate, mass is given to be 9.3, molar mass is 93. So number of moles is 0.1. Here molar mass you have to calculate, molar mass comes out to be 199, then answer will be 19.9 gram. Okay, just equate these two things. Okay, guys. Okay. Okay, everybody. Yes, shall we move ahead? It is 19.9 is approximately 20. No, so answer is 20 here they have written. Right? So next question is identify the product A in the following reaction. Right? You have to identify left because NH2 is missing. In product in left. No NH2 is missing, yeah. No NH2 is missing. This NH2 is converted to N2 positive Cl negative. Here this is linked to this, to the para position, right? Like this. Okay, I have already shown you the reaction here. Right, we have done the reaction here. I think here. Right, this is your N2Cl. HCl will be eliminated. That is how this thing will be formed. So there is no NH2 that is missing, right? Okay, no NH2 is missing there. Now you have, next question is, they are asking you that identify the compound product A in the following reaction. So if we talk about these two things, we know that chlorobenzene will be formed, right? First is NaNO2 plus HCl, diazotization will occur, then Sandmeyer's reaction, chlorobenzene is formed. Now what is this reaction? This is basically Dow's process. Do you remember Dow's process? This is converted to OH, right? So phenol is formed in the end. Fourth is the correct answer, right? Phenol is formed in the end. Next question is, next question important. They are saying that you have this reaction, you have OCHOR here, nitrating mixture you are using, NO2 positive electrophile you have, right? So we know that this is donating the electron, that means it is ortho-para directing. So it will show NO2 on the para position, right, as a major product. Then after you are adding 2Br2 in presence of Fe, what will happen, right? 2Br2 in presence of Fe, then what will happen? Now this is your electron withdrawing, that is your electron donating, right? Then you have to know that what will happen now. Okay. Okay, guys. Now this is the para product, para position is occupied. Dow's method, yes. 13 you are saying? Okay, let us see. So from this you are again adding 2Br2. 2Br2 is added. So this will be Br is attacked on the ortho position. This is what you will get as Q. This will be your Q. Right now they are asking the ratio of number of oxygen atoms to bromine. How many oxygen atom it has? 3 oxygen atoms. Divided by how many bromine? That is 2. The answer is 1.5. If you want to have it, this will be 15 into 10 raised power minus 1. So here you will write 15 into 10 raised power minus 1 is the correct answer. Right? Okay, that will become the correct answer. Is it? Everybody in the chat box, is it? Everybody in the chat box. Okay. So 15 will become the correct answer. Now we are going to do some questions of JEE Advanced, right? What kind of questions they ask you in JEE Advanced, right? Okay, you should always get an idea, right? So that that should not come up as a surprise to you, right? So let us take an idea that what kind of question they will ask you in JEE Advanced, right? So the question is the total number of sp2 hybridized carbon atoms in the major product P of the following reaction. First is LiAl excess, then add H2O, then acetophenone you have added, right? Okay, so let us do this reaction. JEE Advanced question, you try to solve it with me only, right? So this is C triple bond N, this is C triple bond N, this is C triple bond N, and this is C triple bond N. Now we know that what is going to happen when we add water here. When we add water, when we add LiAlH4 here, what is going to happen? This will be converted to CH2NH2, again CH2NH2, right? Pi bond will break, no? So CH2NH2, right? Again here CH2NH2, right? Okay, this will be converted to reducing agent. Very good, very good. Right? Now, you are adding acetophenone. What is acetophenone? Acetophenone means to this phenone, you have this kind of group. This is acetophenone, right? So here you are using this group in excess, right? So can you tell me what will happen? Any idea in the chat box? Any idea in the chat box? Any idea in the chat box? Any idea? So I'll draw it here only, right? So this is acetophenone. This is C double bond O CH3. What will happen basically? The two hydrogens here, and this is the same. Do you remember that reaction? That was NH2Z and this was C double bond O, right? Do you remember this reaction? Do you guys remember this reaction we did in aldehyde and ketones, right? Do you remember this reaction that we did, right? Do you remember this reaction that we did? Okay. Now, what will happen? This 2H2 and 1 oxygen will be removed and it will be C double bond NZ, right? That is the base of this reaction, right? That is the base. So it's the same thing that I'm going to do here. This is the same thing that I'm going to do here. Let us see what I'm going to do here. So basically this oxygen and this nitrogen will leave, right? In this full compound, what will happen, right? To write it here. So this is your 1, this is CH2, right? Nitrogen, this nitrogen is attached to this double bond. Then this carbon is having one CH3 and is having one C6H5, right? Carbon, wait a minute. Here, wait a minute. here you have carbon, then you have nitrogen. Nitrogen is attached to this carbon, yes. Okay, nitrogen is attached to this carbon, CH3, same thing will happen here. CH2, nitrogen, double bond C, CH3, C6H5. Same thing will happen here again, right? This is also same, CH2, then you have this nitrogen that will replace this oxygen. Then you have double bond C, CH3, C6H5, C6H5. Again, here you will have CH2, N double bond C, CH3, C6H5. This will be the level of JEE Advanced. Okay? Okay? Okay, guys. I tried my best to make this easy for you, right? What we did here, here you had LiAlH4. Firstly, we did the reduction. Now, we will use this thing. Oxygen will be replaced by nitrogen, then Z here. What is Z here? This whole thing is Z here. This whole thing is Z here. Not Z, this whole thing is Z. This whole thing is Z, and this is your ketonic part. This is your ketonic part that will stay as it is, right? So this is CH2, this is CH2 to this nitrogen. Again, you will replace this oxygen with this nitrogen, the same that you have done here. This oxygen is replaced by the nitrogen and with Z. This oxygen is replaced by the nitrogen, right? Then you have double bond C, CH3, C6H5. Okay? Okay? Okay. Let us see what was the correct answer here. I think they have not given the option. The answer, total number of sp2 hybridized carbon atom. Now tell me how many sp2 hybridized carbon atom. This is sp2, 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 this is sp2. Now, important thing is that in this benzene ring that we have not drawn here, in this benzene ring also, you will have 6 sp2. 6 sp2. Here also you will have 6 sp2. Here also you will have 6 sp2 because each carbon will be sp2. Here also 6 sp2. So 6, 4, 24 plus 4, 28 sp2 hybridized carbon. Right? 28 sp2 hybridized carbon you will have. Okay? Okay, guys, this is your 2024 question only. Right? 2024 question only it is. Right? Okay? This kind of, be prepared for these kind of questions in JEE Advanced. Next is, consider the following, and don't get scared of this. I know for the first time you will find it difficult. Try to, after this chapter, you will get the PDF of this chapter, right, after this lecture. Then try to solve it yourself. Trust me on that. You will be able to solve it, right? But if you just leave it just like that, right, then I really doubt that, right? You have to solve it yourself also after this lecture, right? So now this is a question based on so many, this is a multiple choice, not multiple, this is multiple answer question, right? So how many correct options? It can be 1, it can be 2, it can be 3, right? So you have NO2 and CH3 that are para to each other. P you have given Q, then R, then S, then HO, then T. Ma'am, we are not able to understand anything. Let us do the hit and trial method here, right? What if P is H2PD and ethanol? Here it is SN, HCl. Here it is this one, right? P is given to be 2 things. What is P is H2PD ethanol? Then you will get Q as, Q will be, if you are using H2PD ethanol, then this will be CH3. This is converted to NH2. With a tin HCl, or you are doing catalytic hydrogenation in presence of ethanol, NO2 group is converted to NH2. That is the value of Q here. So Q is confirmed. If P is this, then Q should be Q is not mentioned anywhere, right? Q is not mentioned. So this is definitely not Q, right? If P is this, then Q is not this. So D is the wrong answer, right? Okay. Now, next is Q you have. Now you are adding R. Now still I am confused. Which is R, ma'am? This is R or this is R, right? Both are same, yaar. NaNO2HCl will form HNO2 only, no? So basically we are doing diazotization. That means S will become equals to diazotization. After diazotization you will get, this is CH3 will remain as it is. This will become N2Cl positive negative. That means this is also right, this is also right. And S will become equals to CH3 N2Cl. This is also right. So B option is definitely the correct answer. Let us see if any other option is correct, right? After this, after forming S, you are adding U. What is U? U is given to be this or this. I told you one thing, that when on the diazonium salt, you add H3PO3, right, PO2, then this N2HCl will be converted to hydrogen. That means you will have toluene, right? So T is toluene. T is definitely toluene. So wait a minute. S is H3PO3. Acha, this one they are asking. After this they are also doing oxidation. Can you tell me what was the oxidation of alkyl substituted benzene? Right, what was the substitution of alkyl substituted benzene? That was convert this COH into COOH. Right? So here with H3PO3 you will have the formation of, this N2Cl will be converted to hydrogen. This, after the oxidation, it will be converted to COH. That means when you use U as this, then this we can form. So that means this is also the correct. That means A is also the correct answer. A is also the correct answer, right? B is also correct, A is also correct. Let us see whether C is correct or not. S formed is this one, this is S, right? T, let us see what is formed. If you do the hydrolysis of this, you add water, what you will get? I told you, right? If you add water, right, what will happen to this N2Cl? Right, this will be converted to OH. Right, that means you will have this thing. This is your T. Definitely it is T. So it is also correct. Now whether this is correct or not. So you are saying you can add H2PO2 to eliminate this thing. See, I'll just do this thing here. This is H3PO2. Right? If you want to eliminate N2Cl with hydrogen, you can use this CH3. Right? Now, can you use CH3CH2OH? Yes. Or you can use CH3CH2OH. Do you remember this reaction? Right? Do you remember this reaction? We have done this reaction somewhat here. Right there I told you that this is your JEE advanced question only. Have we done this? Diazonium salt H3PO2, it will give you benzene. It will give you, this N2Cl will be replaced by hydrogen. Whether you use ethanol, whether you use H3PO2. That's why I told you that these are important, because they are asking you these kind of reactions in a very complex manner, but yes, they are asking you. Right? Okay. Okay, guys. Wait a minute. Where is this reaction? Yes. So, that means this is also the correct answer. That means A, B and C. All of them are correct. A is correct, B is correct, C is correct. Once again, option B. Okay, I'll write everything here. Right, I'll write everything here. See, if you have this thing, that is NO2, and this is CH3. If I am saying P is H2PD or SnHCl, right? Whether P is SnHCl or H2PD, right? Answer will be that this NO2 group will be converted to NH2. Is it? It will be converted to NH2. After this, wait a minute. After this is becoming your Q. So this is my P. This can be P or this can be P, right? And this is Q. This is Q. Now after this, what we are doing? After Q, we are adding some R. I am saying it can be NaNO2 or HCl or HNO2. Both are the same thing only. Either you can see NaNO2 HCl or you can see HNO2 in the reagent side. It will give you, this is N2Cl, that means Diazonium salt will be formed here, right? And now this is your R, right? R can be this or R can be this. It is going to give you this S, right? Okay, I am writing the whole chart here, right? Now, after this, they are saying that if you add water into it, what will be formed? You add water into it. See, simply, if you add water, they should have written warm also here, but no worries, right? So it will form OH, right? And this is CH3, right? And this is, we have T, right? This is T. This is T what we have formed, right? Now, they are saying you need to have benzoic acid, right? You need to have benzoic acid. Now, benzoic acid is formed in two ways. See, if you add H3PO2 or you add CH3CH2OH, both what they will do, they will convert, not from here, it's from this side. Yes, it's from this side, right? From here, if you add it into benzene diazonium salt, what will happen? This will be converted, this CH3 will stay as it is, right? This N2Cl will be converted to hydrogen. Now, after this, they are saying that add KMNO4, right, in alkaline and heat it. That means you are converting this CH3 into benzoic acid, right, into benzoic acid. Now, this is U, right? U can be this thing or U can be this thing. Now, tell me, is this thing clear to you or not? Now, guys, tell me, is this thing clear to you or not? Very, very important question, right? There are high chances that you can mark it you can do mistake in this question because 3 answers are correct, right? It's a multiple answer, right? Okay, yes, these are oxidizing agent. It will place all the alkyl chain that are present here into COH, right? Okay, understood? Everybody in the chat box? Everybody in the chat box understood this or not? Yes. Now let us do some more questions here. Aniline reacts with mixed acid. Now they are saying that aniline will react with mixed acid, concentrated HNO3 and concentrated H2SO4 to give PQ, and this we have done or not. This I told you that you need to remember the percentages also, right? So they are saying that 3 products are formed when it is nitrating. We know that which is the product that is formed in 47%, right? Because they are saying that the major product of the following sequence is the major product. They are saying the major 2%. They are saying R they are using here. Tell me, what was R? R was ortho or para? This is definitely para. This was meta, and R was ortho. R was ortho product, That means to this aniline, you have ortho product. Ortho means this product. This is R. Okay. This is R. R is the ortho product. Okay. R is the ortho product. So ortho product is this one. Right. So they are saying that let's do the reaction of R. Okay. We are doing the reactions for R. R, when it is acetylidation, right? We are doing acylation of that, acetylation of that in the presence of pyridine. So what we will do, right? Again the same thing, right? You will have NH2, this is NO2, right? You're doing the acetylation here, right? So what will happen here? You will have the formation of this NHCOCH3, right? And this is NO2 group, right? Then again what you will do, you will add Br2 here. When you add Br2 here, it will be para-substituted product is formed. We know that when we do the acetylation, after that when we add the Br2, it will be a para-substituted product. So this is NHC double bond O, CH3, this is NO2, and Br is attached here in the para position. After this, what we are doing, this step also done, this step also done. After this, we are doing hydrolysis. After the hydrolysis means adding water into it. This acetylation is removed, right? Hence, you will have the answer as this is NH2, this is NO2, and this is Br. Right? This step also have we done? Students, are you able to understand this or not? This step done, this step done, this step done. Then you have NaNO2HCl, that means diazotization you are doing. Right? Diazotization you are doing. That means NaNO2HCl. That means you will have the formation of this N2Cl positive, right? And this is NO2 and this is Br. Right? After that, you are adding ethanol. Now, can anybody tell me, I have told you this is the previous question as well. When you add C2H5OH and when you heat it, this N2Cl negative, this will be replaced by hydrogen. So basically, you need to have the knowledge, right? You need to have the knowledge of all the reactions. If you know all the reactions of this chapter, then you will be able to answer everything, right? It's just that it is time consuming, right? So it is N is replaced by hydrogen, and hence you have the formation of NO2 here and Br, right? And here they are saying after doing these many 5 processes, you have S. So now this is S, this is R. Understood what is S and what is R? Understood? Yes, everybody? Yes, everybody? Yes, everybody? Understood this or not? What we have done here, right? This is, firstly, we have done acetylation, COCH3, then bromination. Bromination when we do for after acetylation, then para product is formed. After doing hydrolysis, this COCH3 group is replaced by hydrogen again, right? After doing diazotization, this NH2 group is replaced by N2Cl. After doing adding ethanol into it, or they can also say after adding H3PO2. Both will give the same answer, right? Okay, this product is formed. Now we know the answer for S. What is S? We know. But they are not asking you S. They are the major products of the following sequence are. They are asking the value of this major product. Again, we have to do the reaction, right? So, yeah, advanced questions are lengthy, right? So, this is benzene. On the benzene, they will say, ma'am, is there any trick for this? No, there is no trick. If you know the reactions, you can answer. If you don't know the reaction, you cannot, right? Now, we are adding tin HCl. Now, can you tell me after adding tin, what will happen? Anybody? We know that it will reduce NO2 group. Guys, the reactions are very simple. It's just that it's lengthy. It's not a difficult question that you will say, ma'am, it's very complex. It's just a very lengthy question, right? This is Br, this is converted to NH2. After this, what we will do? This step done. After this, Br2 and water in excess, right? In excess, you are adding Br2 and water, right? So this is ortho and para positions. Br2 in excess. In excess, we know that NH2 is ortho-para directing, no? Ortho-para, right? So here what will happen? This is NH2, right? This is bromine, ortho, ortho. This is ortho, this is ortho, this is para. Right? Okay. Everybody in the chat box, is that clear or not? Everybody in the chat box, is that clear or not? Right? Because this is ortho-para directing, you had new Br groups. This step is also done. Then we will convert it into Diazonium. Then we will add H2PO2. Right? Then we will add NaNO2 HCl, that is diazotization, right? Then we know that what will happen? Br will stay as it is. Br is as it is. Br is as it is, right? But on diazotization, this NH2 group is converted to NO. This NH2 group is converted to N2Cl, right? N2Cl, this is positive, this is negative. Now again after this, ma'am, what we are doing now? Again after this, we are adding H3PO2. As I told you, after adding H3PO2, this will be replaced by hydrogen, right? So here what you will have in the end, this is Br, this is Br. It was a lengthy, but it's a very simple question, right? It's lengthy, but it's not like all simple reactions are used here, right? So that means 3 Br and then 1 Br here, right? So what was the answer? D is the correct answer. 1 Br here and 3 Br here. So D will become the correct answer, right? Okay, guys. Okay. Yes, everybody. Yes, everybody. This though we know we have not done this. Right, next question, let us see this next question, everybody in the chat box. Yes, everybody, try to answer this also. Try to answer this, everybody. Everybody, try to answer this. Chalo, let us see. Let us do this again. Simple question it is, right? JEE Advanced. This is NH2. Firstly, they are saying that you are adding acetic anhydride. Acetic anhydride, guys. Firstly, you are adding acetic anhydride. Can you tell me what will happen? Acetylation. That means this thing, here I am just making it as a circle only. And here you will have NH. Hydrogen is replaced by COCH3. Acetylation you have done, right? First step you have done. Then you are adding KBrO3HBr, right? KBrO3. This students will get confused. KBrO3HBr. This is nothing but here you will produce the Br positive as the electrophile, right? This is basically bromination only. Right, so here after the acetylation, when you do the bromination, you will have para-substituted product, isn't it? So para-substituted product is formed, that is Br is attached here, right? After this, next step is doing the hydrolysis, right? After you do the hydrolysis, what will happen? After you do the hydrolysis and heat it, what will happen? This COCH3 group is again replaced with the hydrogen, right? So this is benzene, this is Br, and here it is replaced with this NH2. That is replaced by hydrogen, right? After this, you are doing diazotization, then CuHBr. Diazotization, that is NaNO2 plus HCl. What will happen? This will get converted to N2Cl. This is getting converted to N2Cl, positive, negative. This is Br, right? You just need to have the knowledge of the reagents, okay? You just need to have the knowledge of the reagents. Now, after this, they are saying you are adding CuBr. Now, let us see who can answer this. CuBr, what is this reaction called? In the Diazonium salt, you are adding copper CuBr, CuHBr. Copper powder and HBr. What is this reaction called? Anybody in the chat box? Let me see if you remember this or not. What is this reaction called? What is the name of this reaction? Anybody? Anybody in the chat box? What is the name of this reaction? Anybody in the chat box? Anybody in the chat box? What is the name of this reaction? Gattermann reaction it is, no? Gattermann reaction. Gattermann reaction. This N2Cl will be replaced by Br, right? It will be replaced by Br, and this is the final product that you will have. So answer is B will be the correct answer, right? Okay, B will be the correct answer, right? Very good, Devanshu, very good. No, it's not Rosenmund, it's Gattermann reaction, okay? Yes? Okay, everybody, Sandmeyer was still close. You were still close, right? So, good attempt, right? So, you were still close. Very good, Teja. Okay? Now, let us see this reaction. The following reaction, let me see how many questions we are left with. 2 questions we are left with. Let us see who can answer this. 2 questions we are left with. In a following, these are the questions of JEE Advanced, okay? In the following reactions, the major product W is. What is the major product? Everybody, what is the major product here? Right? When you do diazotization, it will become N2Cl positive. This is negative. Right? So, here, which thing will be formed? Basically, which hydrogen? Firstly, hydrogen of this will not be replaced, this will be replaced. See, para position is occupied, so ortho position it will take, right? So, ortho position, this it will not take, this ortho position it will take, right? Which is like substituted more, that position it will take. So, this position will get linked to the N2. So it will form basically something like this, benzene, or you can just draw this thing here, benzene, N double bond N. Here it will get attached to a benzene, then another benzene, right? But here, what you need to understand, that it will attach to the position next to it. That means OH will be present here. It is present. Wait a minute. Here also OH is present, but benzene should be present here then. So it is not a right answer. Here OH is not attached. Here also they have used another benzene. So here they have used the same benzene, right? So OH is present here, and to the para position, right? This is OH. Wait a minute. This is benzene. Just rotate it. Wait a minute. Okay. So if I mark this, this is 1, this is 2, this is 3. The second position will be attached, okay? So this is 1, 2, 3. So how the product will be formed, right? Because I'm confused between first and second, okay? A and B. So this is N2. Benzene will attach here, right? And next thing will be OH, right? This is 1, 2, 3, 4, 5, 6, right? So this is 1, 2, 3, 4, 5, 6. First and sixth position, you will have this thing, right? So if we talk about this thing here, this is 1, 2, 3, 4. If I say this as the second one, this is 2, this is 1, 2, 3, 4, 5, 6, right? If I say this as this one, 1, 2, 3, 4, 5, 6. So it is between 5 and 6. Between 5 and 6. Here it is not between 5 and 6. The benzene should be between 5 and 6. If I take this as the first one, so benzene should be between 5 and 6. That is only present here, right? Okay. Here it is not even present. That is also the wrong. So A will become the correct answer, okay? A will become the correct answer, right? Okay? Understood? How to do it? Basically, this position will get attached. This position will get attached. So I just, to see that what will be the correct answer, I just marked 1, 2, 3, 4. 1 is attached here, right? 1 is attached here, right? Second position will have OH. Then you have 3, 4, 5, 6. Benzene you have drawn. Between 5 and 6 you have benzene, right? So this will become the correct answer, right? So A will become the correct answer, right? Okay. Yes, guys. Yes. So A is the correct answer. Next is this one. In this reaction, they are saying that in the reaction below, the major products formed is. It's a very simple reaction, okay? It's a simple thing. If you know the concept, you will take just 1 second to answer this. Try to answer this. Try to answer this. Very, very simple question. Very, very simple question. Very, very simple. Try to answer it yourself, guys. Very simple it is. Orthonitrobenzene. Okay. See, acid anhydride means acetylation. So, basically in this case, NH2 group is converted to NHCOCH3, right? So, here this group is converted to NHCOCH3. Here to definitely not. Here also it can be, here or definitely not, right? Here they have done two things here. Here they are saying that this hydrogen will also be replaced by COCH3. I have not taught you any reaction like that. I have told you that amine, the hydrogen of this amine will be replaced by COCH3, not for amide. We don't have anything for amide as such, right? So that is why this will become the wrong and A is the correct answer here. Okay? Okay, guys. No, yaar, I don't know. Right? Abhi to I don't know that. Right? Okay? Is that clear to everybody here? Everybody in the chat box, is that clear to all of you or not? Yes. C, no. C will not be the correct answer because for amide, we don't have as such anything that there is acetylation of amide group. No. Acetylation of amine group we have. Right? Okay? Yes. So guys, we have done a question of JEE Advanced, JEE Means as well, so that you can get an idea that what kind of questions are asked in JEE Advanced and what kind of questions are asked in JEE Means. You can know the difference between them. So as you have seen it here only, because students were asking that, please ma'am pick out the question of JEE Advanced as well. That is why I have picked out some question of JEE Advanced as well, so that you can start preparing from now onwards only. Means and advanced, right? The concept is same only. It's not that the concept is different, right? Some questions are twisted in means as well. Some questions are twisted in advanced as well. But for advanced, yes, the questions are time consuming or they will be little bit twisted, right? But if your base is strong, right? If you have good base, then definitely you have good practice, then definitely you can solve the question of JEE Advanced as well. Right? You just need to have more practice. Okay? 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 I'll tell some other day. Okay? I don't believe in saying. I believe in the actions. I don't believe in words. So you show the actions by attending the class on daily basis, by commenting down, by sharing this to your other JEE aspirants as well. Then I'll believe that you respect me and you love me, right? Because I am that person who believe in actions. And what if I say I love my students, but I am not taking the class, I am not giving you such amazing questions, I'm not solving all the questions in front of you. So the actions will prove that how much I love my students, right? Okay? Yes. Okay then, bye bye guys. See you all in the next class where we are going to do biomolecules, and this is NEET aspirants find it very easy, but JEE aspirants find it really tough, right? Because I was also a non-medical student, so I can understand yet, right? So we will see what kind of questions they ask from JEE Means and JEE Advanced and what is the concept behind that. Okay. Okay then everybody, bye bye, take care, see you all in the next class, bye bye.